Namaste. Welcome to everyone. Welcome to another episode of Navimash podcast. So today, as you can see, we have chosen our topic. It's a very interesting topic that we had actually had discussed in our previous podcast, where we are launching the Ekam magazine, the first Sanatani magazine of Bharat. So where that time we had actually discussed about time and the concept of time. So at that time, actually, I had shown this book to Vijitda. Uh, People who are not familiar with Vijitda is a physicist by profession. He was uh, like doing his PhD in physics. So we will request Vijitda to actually up, apart from working in finance and also writing a book, so he is a physicist. He doesn't teach professionally. I'm maybe not sure, but Vijay will give details about like what he had actually done as a physicist. And then so because actually I asked him to actually please come to our show because you are the right kind of individual who would talk about the concept of time in the Vedic, in the Indic concept, okay, from the Hindu perspective, because he can give both the modern perspective as well as the Hindu perspective. So before I give it to Vijitda, this is the book. This is the book that we are going to not review, but we're going to take concepts from this book and then we are going to deliberate on it, elaborate on it, and we will have maybe multiple shows on this book structure itself. So this is the book. This name is Time, uh, Kāla Darshana, Building Blocks of Time by Ajay Chaturvedi. It's a time series. So there's one more book you can see here. So it's a theology. So this book is called Time and it's called Kala Gati, the cosmic flow of time and history. So, and there's one more book which will come out later. So I had all of these. So I had actually read part of it, not fully. So Bijita, over to you. Thank you for
Sure.
coming. Good morning.
My pleasure. Yes. Can you hear me?
Yes, I can hear you clear. Go ahead.
Okay. Right. So time, right? I mean, in this sort of in this lecture, we are going to talk about time from a physics perspective or a little bit of philosophy perspective. And you know that physics used to be called natural philosophy. So it's basically philosophy which gets entangled with mathematics to predict the functioning and dynamics of physical world. And in this prediction of everything that is happening around us, an unavoidable underlying variable in every equation is time, right? So if I talk about physics, what does it do? Like at the very simplest possible way, in the simplest possible
Bijita,
words. Uh-huh.
Abhijita, before you just go there, because like people are familiar with your persona as an author, but you being a physicist is not something which is well known. Just could you give us a little bit of insight into your persona as a physicist who had learned and got his PhD in quantum physics?
Okay.
No, not yeah. So that people will understand okay, why I have asked you to talk to on this specific topic.
ठीक है. Okay, so right, I am so as you know that I am Bijit and I've written a book basically in history named History of Hindu Myths and Hindu Genocides. But what probably you don't know about me is that I have a PhD in theoretical particle physics. So I did my BTech in engineering physics, which is some sort of an applied physics where I learned semiconductor, optoelectronics, fiber optics, laser, solid state, and all these things that are basically at the intersection between electronics and physics and material science. So this was my BTech from IIT Delhi, and after that I went to Carnegie Mellon, Pittsburgh, to do my PhD in theoretical physics because I felt like my knowledge in theoretical physics is not probably good enough and I need to learn more about physics. So I did a PhD in theoretical particle physics from Carnegie Mellon. My specific area was quantum chromodynamics. So what is quantum chromodynamics? You know, chrome means color, right? So basically, when you try to dissect an atom, you will see ki okay, there are electrons moving around a very small area where there is a nucleus, right? And so if the radius of electron is around 10 to the power 18 minus 8 10 to the minus 9 meter, the nucleus has an sort of, if you can define a radius for that quantum world, it is something around 10 to the minus 14 10 to the minus 15 meter. So 10 to the matlab, there is a gap of 10 to the 6 between the orbit of an electron and a nucleus. But when you can also break a nucleus as well, and when you will be breaking a nucleus, you will see that at the simplest possible scenario. Why I'm saying that, because there are a lot of uncertainty principle and everything involved. But at the simplest possible scenario, a nucleus it consists of three quarks, and these quarks are actually connected through some matlab, gluons. Just like light has photons, so there is something called gluons. So ये मतलब inside nucleus there are three quarks. Inside nucleus there are proton and neutron, and each proton and neutron has three quarks which are actually bound by gluons. So this is basically the area of quantum chromodynamics. You just try to understand the nuclear forces, and you try to go beyond in order to understand how a nucleus get mass. And that is like, okay, by interacting with something called Higgs, right? Then you try to understand what is Higgs, and also you try to understand how the universe was originated. Because when the universe was sort of very small, you know that universe pretty much was created from a singularity, and then it started to expand. And when it was expanding, it went to different phase transitions. So initially there was a singularity, and at that point, what happened, we don't know. The physics doesn't know yet. We have some guesses, but those are not proven yet. But there was a time where everything around us was basically proton and a small amount of neutron. Okay. Then when the universe further expanded, so these protons and neutrons got separated from each other. They sort of cooled down, which then created atoms, the hydrogen atoms, the very simplest possible scenario, and then the universe further expanded to pretty much become a vacuum. Okay, so this was the area that I dealt with. And yeah, so as theoretical physicist, you know what we do. eh, I mean, every theoretical physicist, everyone pretty much in who are doing physics, they solve equation of motion, right? Now, what is equation of motion? Equation of motion is basically saying ki, acha, this particle is here at t equals 0, where it is going to be or what it is going to do at some other time, t equals some t1, which is greater than 0. So, I mean, as physicists, this is our only job, solving the equation of motions, right? And when you're solving the equation of motion, you're solving something related to motion. And when you talk about motion, you have to bring time as a unavoidable sort of matlab, unavoidable intrinsic variable. Okay. So that's why time is important in physics. You so
Yeah.
basically physics, in my view, has two basic components. One is the dynamics, and another is symmetry. So in symmetry, you basically check, you use group theory. ग्रुप थ्योरी में क्या होता है, यू चेक कि अच्छा इस पार्टिकल को कोई भी एक रैंडम मतलब एक हिल्बर्ट स्पेस हो सकता है, फिजिकल स्पेस हो, इसमें ऐसे घुमा दूं तो एक लगेगा कि नहीं. For example, we call ki proton and neutron are similar, although they have some electric charge. But if you remove that electromagnetism part, that electric charge of proton, they will be exactly similar. जिसे SU true symmetry कहा जाता है. ये एक abstract space है, उसमें proton और neutrons are like the two side of a same coin. ठीक है. So this symmetry part is important. यहाँ पे dynamics नहीं चाहिए होता है. You just detect कि which are the events which that look similar and that are similar. You basically analyze it through a group theory. मतलब you analyze it through group theoretical language. So that is the symmetry part, and the next part is dynamics or the interaction, and that is probably the most essential part. So the group theory part, the symmetry part actually eases up the problem. So basically, you segmentize and group the group a large number of problems into specific, like a smaller number of problems, and then while solving it, you try to see ki how these things are interacting with each other. For example, how proton and neutron interact with each other. If they're similar, and then proton got a electric charge, positive electric charge, now what is going to happen? Now what is the dynamics? That dynamics, that interaction part, to sort of calculate it, you need time. Okay, so since time immemorial, whenever people started to talk about matlab, physics with more rigor, they have introduced time. Now, what was time according to sort of classical physics? So in classical physics, so okay, before classical physics, you know that the Indian philosophers and Indian astronomers, they have also talked about time. I mean, Indian spiritual leaders have also talked about time. I'm going to discuss it a little later, along with whatever I'm discussing now, because what Indian philosophers talked about time actually is going to come back in modern day 19th 20th century, when physicists were talking about physics. Okay, so I'm going to come, but only in the context of modern physics. In the classical physics, in the Newtonian physics, Newton considered time to be a very linear and universal. So time is basically, according to Newton, there is a universal clock, right? And that universal clock is everywhere. It is ticking at the same rate, no matter what you do. It is dissociated from the dynamics of the particles. It is as if this is something divine. You what you do is like, you take care of that. You just look at that clock, that universal ticking, to record your time interval, and then you see a particle moving in space time. You record the motion, and from there you develop some equation of motion. So you define things like velocity, then you define things like momentum, then you define as like mass times velocity. Then you define something like acceleration, right? And then you, from the observation, pretty much you, and using a some amount of calculus, you can derive the three equation of motion, right? The when you have an acceleration, right? The Newtonian equation of motion, right? So here in the clock is basically completely separated from the particle, from the space-time around us, from the events that are happening, from our own interaction, everything. Now, this idea got changed. I'm just going to give you a brief summary first. Then I'm going
Yeah.
to delve into the philosophy of it, because time is something which we don't know what it is. We cannot define it properly, but it has a huge consequence. I mean, it is an open question, and I still believe in order to develop a single theory of quantum gravity, which is called the grand unified theory, you have to first understand time. We don't have a good idea of what time it is actually. So yeah,
Okay.
so
Okay. Just
parallelly,
one interjection. So people, most of them are not from the STEM background. So grand unified theory give 1 minute explainer because it will
acha
keep
acha,
in slow.
right. So you know that we have various kind of equations, like we have Maxwell's equations
No.
to
Okay, okay. Wait. So we have four fundamental forces of nature. Okay, that
right.
I will mention, and we have able to actually integrate electromagnetism. So you have electricity and magnetism being merged. Okay, then you have a Maxwell theory of uh, what was it?
मैं
Electrodynamics.
बोल देता हूँ. So
Yeah, right.
initially what happened, electricity was discovered, right?
Mm,
So
mm.
and magnetism was there already since time immemorial, right? People knew about magnetism. Electricity was discovered and it was utilized very effectively. तो इलेक्ट्रिसिटी मैग्नेटिज्म, इन दोनों का अलग फिजिक्स चलता था. इनके इक्वेशंस अलग होते थे, इंजीनियरिंग एस्पेक्ट अलग होता था. देन देयर केम दिस, और फिर और एक फोर्स चलता था जिसको ग्रेविटी कहा जाता है. तो बहुत पहले से इंडियन जानते थे, बट जिसको पॉपुलराइज किया न्यूटन ने. um, और इसके श्लोकास भी है which we can already cite, and I would refer to the book The Imperishable Seed, which is recently published, to for my claim कि इंडियंस पहले से ही अपने ग्रेविटी के बारे में जानते थे. बट एनीवे, science is science. It is not Indian or European. It doesn't matter. So Newton popularized gravity. Gravity का अलग force है. राइट. इलेक्ट्रिसिटी अलग फोर्स है, मैग्नेटिज्म देन डिस्कवर हुआ, वो अलग फोर्स है. देन मैक्सवेल नाम का एक बंदा आया, ही यूनिफाइड, ही शोड कि ये जो इलेक्ट्रिसिटी है और मैग्नेटिज्म है, दे आर एक्चुअली द मैनिफेस्टेशन ऑफ अ सेम अंडरलाइंग फोर्स. तो इलेक्ट्रिसिटी और मैग्नेटिज्म के लिए एक तरह का इक्वेशन लिखा जा सकता है. ही गेव 4 इक्वेशंस which merged electricity magnetism. क्यों? क्योंकि वो हिंट हमें मिल रहा था कि इलेक्ट्रिसिटी कैन प्रोड्यूस मैग्नेटिज्म बिकॉज a moving, who is that, just give me a second. So electricity, हाँ, तो मैं क्या बोल रहा था कि we had the hunch कि electricity, a moving charge can produce magnetism, and also magnetism can produce electricity, like in transformer for example. So people were actually having doubts कि ये चल क्या रहा है. Then Maxwell came and Maxwell said कि भाई these are the manifestation of the same underlying force which is the electromagnetism. फिर क्या हुआ, फिर एक दूसरे तरीके का फोर्स डिस्कवर हुआ जिसे स्ट्रॉन्ग फोर्स कहा जाता है. ठीक है, स्ट्रॉन्ग फोर्स में जिसमें मैं बोल रहा था कि प्रोटॉन और न्यूट्रॉन न्यूक्लियस के अंदर है, प्रोटॉन पॉजिटिवली चार्ज्ड है, इतने सारे प्रोटॉन न्यूक्लियस के अंदर रह सकता है कैसे? बिकॉज इफ दे आर लाइक, आई मीन दे ऑल आर पॉजिटिवली चार्ज, द रिपल्शन विल बी ह्यूज. सो देन दे डिस्कवर्ड कि अच्छा नहीं, प्रोटॉन और न्यूट्रॉन न्यूट्रॉन प्रोटॉन प्रोटॉन इनके बीच एक स्ट्रॉन्ग फोर्स काम करता है जिसे, विच इज बेसिकली द न्यूक्लियर फोर्स दैट बाइंड देम टुगेदर. And this nuclear force is much stronger than the electromagnetic repulsion between the protons. तो फिर एक स्ट्रॉन्ग फोर्स आया, फिर धीरे धीरे वीक फोर्स आया. वीक फोर्स कैसे आया कि काफी टाइम देखा गया कि न्यूक्लियस के अंदर से इलेक्ट्रॉन निकलता है जिसे बीटा इलेक्ट्रॉन कहते हैं. द पॉइंट इज, इलेक्ट्रॉन ऐसा पार्टिकल है, उसका मास इतना कम है. इफ यू यूज समथिंग कॉल्ड हाइजेनबर्ग प्रिंसिपल, मतलब क्वांटम मैकेनिकल पार्टिकल में मास जितना छोटा हो जाता है, उसका उसका मोमेंटम निकालना उतना मुश्किल होता है. एक सेकेंड.
Yeah, so till Bijit takes that thing, we will just talk about little bit more about this book itself. So let me show you where the book is available first. So this is something important. That this is a very very interesting book actually. This is not very technical book which is written. Yeah, Bijit, that thank you. You're back.
हाँ, तो बीटा इलेक्ट्रॉन जैसे निकलता है, राइट. तो बीटा इलेक्ट्रॉन का क्या होता है? बीटा इलेक्ट्रॉन न्यूक्लियस के अंदर से निकलता है, बट बीटा इलेक्ट्रॉन वो लगा कि ये क्रिएट नहीं हो सकता बिकॉज द अनसर्टेनिटी इज सो लार्ज. जस्ट इमेजिन, मतलब जो फर्स्ट ऑर्बिटल होता है एक न्यूक्लियस के बाहर, जो पहला इलेक्ट्रॉन का ऑर्बिटल होता है जिसे बोर इलेक्ट्रॉन कहा जाता है काफी टाइम, वो एक्चुअली उसका अनसर्टेनिटी के हिसाब से वो सबसे मिनिमम रेडियस दैट इट कैन हैव. ओके, बट तब देख रहा है कि न्यूक्लियस के अंदर से बीटा इलेक्ट्रॉन निकल रहा है. हाउ इज इट इवन पॉसिबल? तब निकाला गया कि अच्छा, दिस इज ड्यू टू अनदर फोर्स जिसे वीक फोर्स कहा गया है. कि जब इलेक्ट्रॉन भी निकलता है, उसके साथ और एक पार्टिकल निकलता है जिसे न्यूट्रिनो कहा जाता है. दे बोथ फील अ डिफरेंट काइंड ऑफ फोर्स जिसे वीक फोर्स कहा जाता है. तो ये चीजों को स्ट्रॉन्ग और इलेक्ट्रोमैग्नेटिज्म से डिस्क्राइब नहीं किया जा सकता. वी हैव टू sort of introduce a new kind of force to actually understand the neutrino emission and the beta electron emission. और जो इंडिगो फर्मी ने किया था, इंडिगो फर्मी ने प्रेडिक्ट किया था कि एक अलग तरह का पार्टिकल हो सकता है जिसे बाद में न्यूट्रिनो डिटेक्ट किया गया और नाम दिया गया. तो ये 4 तरह का फोर्स है. 4 तरह के फोर्स के लिए 4 तरह का इक्वेशन लिखा जाता है. बट देन देयर वाज दिस पाकिस्तानी गाय नेम अब्दुल सलाम, जिसको अहमदी होने की वजह से बेइज्जत होना पड़ा पाकिस्तान में. सो दिस गाय अब्दुल सलाम ग्लासो, वो वाज फ्रॉम यूके, एंड वाइनबर्ग फ्रॉम यूएस. ग्लासो वाइनबर्ग सालाम मॉडल एक है जिन्होंने इलेक्ट्रोमैग्नेटिज्म वीक फोर्स को कन्वर्ट किया, जिसको इलेक्ट्रो वीक फोर्स कहा जाता है. नाउ यू हैव इलेक्ट्रो वीक फोर्स, यू हैव स्ट्रॉन्ग फोर्स, यू हैव ग्रेविटी. फिर बाद में स्ट्रॉन्ग फोर्स को देखा गया कि स्ट्रॉन्ग फोर्स और जो इलेक्ट्रोविक फोर्स है, दे सॉर्ट ऑफ ओबे सिमिलर सॉर्ट ऑफ इक्वेशंस. ठीक है, एंड दे फॉलो सिमिलर सॉर्ट ऑफ फिजिक्स. तो वो इलेक्ट्रोविक भी और स्ट्रॉन्ग फोर्स भी यूनिफाई हो गया. नाउ हमारे पास बचा है इलेक्ट्रो स्ट्रॉन्ग वीक फोर्स एंड ग्रेविटी. ठीक है, सो इलेक्ट्रो स्ट्रॉन्ग वीक फोर्स, इसका डिस्क्राइब करने के लिए जो फ्रेमवर्क है, इसे क्वांटम फील्ड थ्योरी कहा जाता है. सो व्हेन यू स्टार्ट टू मर्ज द क्वांटम मैकेनिक्स विद रिलेटिविटी, क्वांटम मैकेनिक्स जो मतलब दोनों एरिया आइंस्टाइन का ही डिस्कवरी है. सो व्हेन यू स्टार्ट टू मर्ज देम, तब जो फ्रेमवर्क निकलता है उसे क्वांटम फील्ड थ्योरी कहा जाता है. तो ये तीन फोर्स क्वांटम फील्ड थियरी के फ्रेमवर्क में आ गया, ग्रेविटी अभी भी नहीं आ रहा है. So it is the ambition, the greatest objective of a physicist, a theoretical physicist, to unify gravity with the other three kind of forces. ठीक है. और ये जो हाइपोथेसाइज किया गया है कि देयर विल बी वन इक्वेशन which will be describing this sort of unification of the gravity and the quantum field theory, उसको ग्रैंड यूनिफाइड इक्वेशन कहा जाता है. एंड ऑल्सो बिकॉज ग्रेविटी में ग्रेविटी होता है विच एक्चुअली ऑल्टर द स्पेस एंड टाइम इटसेल्फ, जो मैं अभी थोड़ा बाद में बताऊंगा. तो यहाँ पे पंगा ये हो जाएगा व्हेन यू विल बी डीलिंग विद द स्पेस एंड टाइम एज अ वेरिएबल, वो अपने आप चेंज होता रहेगा. सो इट विल बी वेरी डायनामिक इक्वेशन एंड इट विल प्रोबेबली लीड टू रीडेफिनेशन ऑफ टाइम इटसेल्फ. ठीक है. एंड उससे ग्रैंड यूनिफिकेशन कहा जाता है, जिसमें ग्रेविटी को एक क्वांटम फील्ड थ्योरी माना जाएगा. सो ग्रेविटी का अभी भी एग्जिस्ट करता है विद इन द क्वांटम फील्ड थियोरिटिकल फ्रेमवर्क, बट उसमें काफी एनोमलीज आता है. इसलिए ग्रेविटी इज कॉल्ड समथिंग नॉन रीनॉर्मलाइजेबल फील्ड थियरी. मतलब ग्रेविटी को प्रेडिक्ट करने के लिए अभी जो हमारे पास फ्रेमवर्क है, उसमें वी नीड इन्फिनिट नंबर ऑफ ऑब्जर्वेशंस टू स्पेसिफाई अ ग्रेविटी फोर्स. But what physics is trying to do, ki can gravity be described with let's say finite number of observations like other three cases. तो ये बेसिकली शॉर्ट हिस्ट्री ऑफ यूनिफिकेशन एंड द ग्रैंड यूनिफाइड थियरी, जिसे गट कहा जाता है. अच्छा, हम लोग कहाँ थे? हम लोग
Okay,
न्यूटन से चल
okay.
दिए थे.
Before we proceed, so you have four fundamental forces of nature: the weak force and strong force of nucleus. You have electricity, electromagnetism, and then you have gravity. So these are four fundamental forces which governs the whole prakriti, okay, or the whole world. So out of these, three are can be described by quantum mechanics. Okay, the one force, gravity, which is not cannot be
Three can be
described.
described by quantum field theory, which is
Oh
a
yeah, quantum field
where
theory.
you
Yeah.
merge
So
the quantum mechanics and relativity,
yeah,
special
so quantum
relativity.
yeah, so quantum field theory, which is able to actually amalgamate and describe these uh, um, weak force of the nucleus and strong force of nucleus and electromagnetism. Okay, where you see the spectra of electron, where you can see the colors. Okay, easily. Now the only gravity which is cannot be described by quantum field theory. So people, and that's called the grand unified theory. If quantum field theory is able to describe in an equation how gravity functions within the scope of an of a scope of an atom, then we will have grand unified theory where you will be able to have one equation which will be able to describe all four fundamental forces of nature. As of now, where we stand. So yes, please go ahead, please.
राइट, एग्जैक्टली. सो मतलब जैसे मैंने बोला कि अगर इफ यू मर्ज द क्वांटम मैकेनिक्स विद स्पेशल रिलेटिविटी, फिर वो क्वांटम फील्ड थियरी निकलता है. बट ग्रेविटी के लिए और एक पॉइंट है कि यू हैव टू मर्ज द क्वांटम मैकेनिक्स विद जनरल रिलेटिविटी. जनरल रिलेटिविटी मतलब it's a thing where the space and time themselves are bending and warping and all sorts of things are going on. Space time is not a Euclidean concept, it's not linear anymore, but they have their own dynamics due to the masses around them or masses in them, within them. ठीक है. तो इसके लिए प्रॉब्लम आ जाता है ग्रेविटी में, जो हम लोग थोड़े बाद में आएंगे. इसके जो मैं धीरे धीरे फिलोसफी को जहां ले जाऊंगा, तो उस साइड से भी आई विल, बिकॉज अ लॉट ऑफ थिंग्स कन्वर्ज राइट टू गिव अ सिंगल थियरी. तो अभी जैसे हम लोग डिस्क्राइब कर रहे हैं कि व्हाट इज टाइम, और फिर हाउ टाइम वाज परसीव्ड इन डिफरेंट डिफरेंट टाइम, राइट. जैसे न्यूटन के टाइम में टाइम वाज लीनियर, it was universal, it was flowing with uniform rate, and it was being determined by a universal clock. ठीक है. तो मतलब एक क्वेश्चन आया था, जैसे न्यूटन वाज बॉदर्ड अबाउट वन थिंग कि द सन इज लाइक सो फार अवे फ्रॉम द अर्थ. How does it know कि there is an earth so far away that I have to send some sort of attractive force to keep it within my territory, राइट. मतलब सन को तो पता कैसे चल रहा है, इतने दूर एक ये बैठा हुआ है, तो कोई एक्सचेंज तो चल रहा है ना कुछ. कुछ तो चल रहा है, मतलब द अर्थ विल बी सेंडिंग समथिंग टू द सन। और दूसरा क्वेश्चन ये था कि अच्छा फिर अर्थ में जो ये घड़ी चल रहा है, द मतलब inhabitants of the earth, we have our own watch. How does the sun know कि it is the same watch that we have to follow? फिर उन्होंने बोला, न्यूटन सेड कि यू सी द there is a universal time which is sort of a river which is flowing with uniform speed. Time is a scalar, that's why I'm using the word speed. एंड उसके हिसाब से सारे जो दुनिया का जो सेलेस्टियल डायनामिक्स है उस हिसाब से मूव करता है। एंड देन बट स्टिल इट डज नॉट गिव यू द डेफिनेशन ऑफ टाइम। if I ask Newton what is time, Newton would not be able to give me what is time, the definition of time. um, but what he found out कि there is a universal attribute to something called time. Now फिर फिलोसफी होने लगा। फिलोसफी में जैसे क्लासिकल फिलोसफी परसीव टाइम एज समथिंग, मैं ये कोट करता हूँ, देयर इज अ वेरी नाइस कि हाँ, टाइम टाइम इज व्हाट कीप्स एवरीथिंग फ्रॉम हैपनिंग एट वंस। ठीक है, यहाँ पे टाइम को इवेंट के हिसाब से बोला गया है कि टाइम एक्चुअली सब कुछ को एक साथ होने से रोक देता है। ठीक है, it is its medium is motion, constant and cyclonic, in which events are held separate by the sheer force of ongoingness, like leaves in a fall whirlwind. So if you see a fall whirlwind, जैसे वो जिसे घूर्णवात कहा जाता है, तो घूर्णवात जब घूमता है you will see कि अलग अलग जगह पे अलग अलग पत्ता होता है, राइट? सो अगर वो घूर्णवात ना रहा तो सारे पत्ते एक जगह थे। इट इज बिकॉज ऑफ दैट साइक्लोनिक मोशन जो काफी टाइम दिखता है गांव में जब बहुत गर्मी होती है। यू विल सी दैट थिंग, you will see कि there is a proper segmentation and sequence of the leaves within that Ghurnavat. So, so this philosophy is saying time is just like the cyclone which is keeping things in sequence. But again, this is a retrospective definition of time. एंड फिर चलता रहा। फिर टाइम आया कि अपना मैक्सवेल का टाइम आया। मैक्सवेल कौन सा बंदा था जो हमने अभी बोला कि जिन्होंने इलेक्ट्रिसिटी और मैग्नेटिज्म को यूनिफाई किया, हु सॉ कि दे कैन बी एक्सप्लेन्ड बाय सेम अंडरलाइंग इक्वेशंस, एंड द डायनामिक्स बिटवीन इलेक्ट्रिसिटी एंड मैग्नेटिज्म इज इमर्जिंग फ्रॉम एन अंडरलाइंग सिंगल मैकेनिज्म ऑफ इलेक्ट्रोमैग्नेटिज्म। ठीक है, सिंगल फेनोमेना। तो इसने फिर जब मैक्सवेल जब काम कर रहा था, मैक्सवेल ने एक चीज नोटिस किया। उसने ये नोटिस किया कि अगर हम लोग, ही फाउंड कि लाइट इज एन इलेक्ट्रोमैग्नेटिक वेव। फर्स्ट ऑफ हिज ग्रेट डिस्कवरी वाज दैट उससे पहले लाइट को पता नहीं था कि इलेक्ट्रिसिटी मैग्नेटिज्म के साथ लाइट का कुछ लेना देना है। Although light or some sort of rays were being created from different electric and magnetic phenomena, it was the discovery of Maxwell through his genius and through the usage of his own equations. He saw कि अगर जो मैक्सवेल इक्वेशन है उसे सॉल्व अगर करते हैं टू फाइंड आउट द इक्वेशन ऑफ मोशन ऑफ सम एब्स्ट्रैक्ट क्वांटिटी, उस जो क्वांटिटी है वो जो एंटिटी वो एज्यूम किया है उसका एक स्पीड आता है। ठीक है, उसका एक वेलोसिटी आता है, और वो वेलोसिटी लाइट के वेलोसिटी के साथ मैच कर जाता है। ओके, सो देन ही सेड कि अच्छा, आई एम गेटिंग एन इक्वेशन by solving my own four equations that I have given of electromagnetism. And if I solve them, what I'm getting ki the speed of propagation, the velocity of propagation of electromagnetism is same as the velocity of propagation of light. So maybe light is a electromagnetic wave. ठीक है, ये जब डिस्कवर हुआ इसके बाद और एक एनोमेली आया। व्हाट वाज दैट एनोमेली? नेक्स्ट एनोमेली वाज दैट वो जो इक्वेशन मैक्सवेल ने लिखा, it was giving the speed of light as c, as a constant of that equation. It was not giving the speed of light from a specific framework. Gave the speed of light as a constant quantity irrespective of your choice of framework. So what do I mean by this? So Newton अगर कहा था कि if you are standing for a bus in a bus stop, let's say, right, and the bus comes. So let's say you are standing, so your velocity is zero, the bus is coming, so the velocity is v, so the relative velocity is v minus zero equals v. Now let's say you are missing the bus. The bus is running with a speed of v1 and you are chasing with a speed of v2. Then the relative velocity is v1 minus v2. So the speed of the bus with respect to bus stop is v1, but the speed of the bus with respect to you is v1 minus v2 because you are moving with a velocity, running with a velocity of v2. So the speed of the bus is not an absolute thing; it is a relative thing. Velocity is always relative. Whenever you are specifying a velocity, you have to specify it as per a reference frame. Is it the reference frame of the bus stop or is it the reference from me of me chasing for the bus? So velocity is always relative. But what Maxwell got in his equation, he got a constant which is c, and that c was independent of the reference frame. And it was so anomalous that people started doubting the Maxwell's equations. Now around 1900, so I think Maxwell died in 1879, if I'm right. I have to check. Don't quote me, but he
Mm-hmm.
died around that time. I think Einstein was born in 1879. Okay, so I have to check. I think Maxwell died in 1876 or something. So the point is, Maxwell was new around 1900. His theory was only a decade old, and by that time, Newton's equation of motion were almost 3 decade old because Newton was from 1542 to 1627, I guess. So, हाँ, तो Newton's equation was around 2.5 decade old by that time. तो यहाँ पे जो हुआ, न्यूटन बोल रहा है कि नहीं, वेलोसिटी हैज टू बी फ्रेम डिपेंडेंट, बट देन देयर इज अ न्यू थियरी ऑफ मैक्सवेल व्हिच इज सेइंग कि वेलोसिटी ऑफ लाइट इज इनवेरिएंट with respect to all inertial reference frame, all reference frame which are moving with a constant velocity. Now लोग फिर इस पे मैक्सवेल पे उसके इक्वेशन पे डाउट करने लगे, but then there was a guy, a patent clerk from Germany named Einstein, who had nothing to lose pretty much. He put his bet on Maxwell than Newton. तो उन्होंने बोला कि नहीं, मैक्सवेल शायद सही हो सकता है, न्यूटन में गलती हो सकता है, बिकॉज न्यूटन ने जो किया है, न्यूटन थिंक्स कि टाइम इज एन एब्सोल्यूट आइडिया व्हिच मे नॉट बी ट्रू. ठीक है, मतलब he is so non-intuitive thing. He said कि he thought कि time may be because time, उससे पहले डेविड ह्यूम इन लोगों का फिलोसॉफिकल काम आ गया था जो एक्चुअली इनकार कर रहे थे फिलोसॉफिकली, दे वर डिनाइंग कि टाइम कैन बी एन एब्सोल्यूट आइडिया because time is dual to movement, right? It is dual to motion. So if the motion is slow, time will be perceived as slow. If the motion is fast, time will be perceived as a fast process. It's as simple as that. Matlab, in the absence of everything around you, you will perceive time as a ticking of your biological process. And if you're running, let's say, in a vacuum, time will be moving fast, let's say, right? Because of your ticking, the ticking will be fast. But if you are doing nothing, absolutely nothing, then there is no concept of time because you are not moving at all. So, yes, but because Einstein went into studying David Hume and all other philosophers, contemporary modern philosophers, he thought कि maybe time is not an absolute idea. तो शायद जो न्यूटन बोल रहा है उसको थोड़ा, मतलब his idea of universal time, उसे थोड़ा change करने की जरूरत है. And so what he did, he actually, um, so इनका जो इन्वेंशन था कि स्पीड ऑफ टाइम इज इनवेरिएंट, आइंस्टाइन ने दो, आइंस्टाइन postulated two things. One is that the, कुछ आवाज आ रहा है क्या मेरा?
No, no, no. All fine, all fine, all fine.
अच्छा अच्छा, तो आइंस्टाइन postulated two things. One is that the all natural processes are invariant with respect to all inertial reference frames. विच मीन कि मतलब जो इनर्शियल जो फ्रेम है तुम्हारा रेफरेंस फ्रेम इन विच यू आर सिटिंग एंड राइटिंग इक्वेशन, if it is static or it is moving with some सम यूनिफॉर्म वेलोसिटी, तो वो जो फिजिकल प्रोसेसेस नोटिस करेगा, that will be similar. It is a very intuitive thing, right? कि if you are in a lift, right, and if the lift is static or the lift is moving with a uniform velocity, तुम्हारा जो you will see your own weight as the same. But when the lift is moving with a acceleration, let's say if it is having free fall, then your weight will be what? Zero. The spring balance will show zero weight if you are moving in a free fall. So, but if you are moving with constant velocity or the lift is static, it will show your exact weight, the way you define exact weight. Okay, which means कि uh, all the और इस तरह से if a magnet is attracting something with a force, no matter whether you are I mean, if the magnet is attracting an iron with a force, let's say the force is F, the lift, if it is moving with a constant velocity or if it's static, it will record the same amount of force. Probably they will have different explanations because electromagnetism जो है वो डिपेंड कर जाता, इंटरप्रिटेशन डिपेंड करता है कि इलेक्ट्रिक फोर्स है या मैग्नेटिक फोर्स है बेस्ड ऑन द रेफरेंस फ्रेम, बट द फोर्स दैट समथिंग फील्स is going to be the same. Yeah. So, for example, induced electricity, right? So, let's say you have um,
Okay,
right, you have a
what
magnet.
you need to just tell what is induced electricity.
Ha ha.
Like
So, let's say
when
you
you
have
play
a magnet.
electricity by putting by creating some effort by yourself, you are creating it, not naturally occurring.
Ha ha. So, let's say you have a magnet. ठीक है? A magnet, and then you have a coil here. So you have a magnet and you have a coil here, and so there is some electricity moving through that coil, due to which there is, so if me as a static observer, I will see ki there is a coil. Let's say there are two coils, one is having some electricity, तो इसके इलेक्ट्रिसिटी की वजह से आई विल सी कि अच्छा देयर इज एन इलेक्ट्रिसिटी, दैट्स व्हाई देयर इज मैग्नेटिज्म. सो व्हेन आई ब्रिंग इट टू अ सेकेंडरी कॉइल, इट इज induce some magnetism within the secondary coil. That is the basis of transformer, right? But let's say when you are, so then you will write some equation and you will find out the force between these two coils in terms of the induced magnetism, right? Now, someone who is sitting, let's say, in the reference frame of this coil, right? So, which is actually the primary coil, which is having some electricity. तो वो देखेगा कि अच्छा there are electric charges, but probably they are not moving as fast. ठीक है? So that guy will start to interpret some amount of this induced force as being generated by the charged particles. So पहला observer बोलेगा this is a purely magnetic phenomena. Second observer sitting on the frame of the coil, sitting on top of the primary coil, will say कि अच्छा it is the same amount of force, I agree, but it is due to electromagnetic phenomena. There is some magnetism and there is some amount of electricity due to the charged particle within the primary coil. कुछ क्वेश्चन आया था क्या? या
No, 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 no,
should we
no.
take
There are
or
no questions.
should I go
No,
on?
no, no, no,
अच्छा
no.
अच्छा
There is. We'll take it later. We'll just finish this because I think it
ठीक
will
है.
take a bit time. So if anything
ठीक
comes,
है.
I will update you. I'm
राइट,
keeping a
मैं
note.
बेसिकली पूरा चीजें बता रहा हूँ इसलिए थोड़ा टाइम लग रहा है, बट एनीवे,
I
सो
don't
इट इज एन इंटरेस्टिंग डिस्कशन, राइट? वी शुड हैव एन एपिसोड. वी डिजर्व एन एपिसोड एनीवे.
know.
तो फिर व्हिच मींस कि दोनों बंदा जो है, टू पीपल सिटिंग ऑन डिफरेंट रेफरेंस फ्रेम, दे आर रिकॉर्डिंग सेम अमाउंट ऑफ फोर्स, बट द रीजन दैट दे आर सेइंग कि इसलिए इतना फोर्स आया, दैट रीजनिंग इज डिफरेंट, right? So all the physical processes that are happening, those are invariant. मतलब जो force जो impart हो रहा है, दोनों frame वो same amount of force record कर रहा है. They are seeing कि these two coils are being attracted with the same amount of force to each other, but the reasoning जो दिया जा रहा है वो अलग है. जो it is a frame dependent description. ठीक है? So So that's why Einstein said कि all the physical processes, the observable processes that are happening, they are invariant with respect to inertial reference frame. Second जो postulate लिया, वो बोला कि the speed of light is invariant in all inertial reference frames. ठीक है? So which is the मतलब genius of Einstein. This second postulate, he just postulated it. Okay. So what is the second postulate? Second postulate is that कि let's say I have a torch. ठीक है, मैंने torch जला दिया, torch से ray निकला, और that ray is propagating at a speed of light, which is around 3 lakh kilometer per second. Now Bhupenda is actually moving with a speed, let's say, मतलब he is in a मतलब futuristic space shuttle which is moving at what 1.5 lakh kilometer per second. So the speed of light is 3 lakh kilometer per second. Bhupenda is moving with 1.5 lakh kilometers per second, and Bhupenda has a torch as well. So we are sitting right here. Bhupenda is going to launch his space shuttle now, which is instantly going to get the speed of 1.5 lakh kilometer per second. We both are having a torch, and we lit it simultaneously. And Bhupender just got ejected, right, with a speed of 1.5 lakh kilometer per second. तो ऐसा लगता है कि दोनों ने टॉर्च जलाया, तो भूपेंद्र का टॉर्च से जो लाइट निकला, दैट शुड हैव अ वेलोसिटी ऑफ 4.5 lakh kilometer per second, because Bhupenda is moving towards the this beam with an additional speed of 1.5 lakh per second. बट आइंस्टाइन ने एक्चुअली इसको नेगेट कर दिया. आइंस्टाइन ने बोला नहीं, दोनों का टॉर्च है और उससे दोनों से लाइट ही निकल रहा है. सो बोथ लाइट as observed by both of them will have a velocity of 3 lakh kilometer per second, and that is a frame independent description of light's velocity. It is very counterintuitive, but इससे कुछ कुछ चीजें हुआ, इसका कुछ implications है in physics, in the area of physics, in the area of philosophy as well, in the area of how we perceive anything around our nature. पहला implication क्या है? पहला implication ये है जो मुझे मतलब if I think it that way, it helped me to understand modern physics actually. पहला implication ये है कि nature allows only a maximum speed limit. ठीक है, नेचर में स्पीड लिमिट का एक मतलब स्पीड का एक लिमिट है, एंड नेचर ओनली अलाउज दैट. अब थोड़ा इस पे थोड़ा इफ आई डिग डीपर एंड इफ आई बिकम अ वेरी रोमांटिक फिलोसोफर अबाउट नेचर, ये किस लिए हो रहा है? सो मैं ये बोलूंगा कि सी दिस इज अ फैक्ट, आई एम जस्ट प्रोबेबली रोमांटिसाइजिंग इट, आई डोंट नो, बट मेरा फिलोसफी ये रहेगा कि नेचर इज अलाउइंग अ मैक्सिमम स्पीड लिमिट ताकि एवरीथिंग डजंट हैपन एट वंस. Because nature wants probably a sequence of events. Nature does not want कि all events or everything fall onto each other. ठीक है, ताकि सारे इंटरैक्शन इंस्टेंटेनियस ना हो जाए. उससे रोकने के लिए नेचर अलाउज some superior force, whatever, nature allows a maximum speed limit. अगर मैक्सिमम स्पीड लिमिट ना होता, अगर सब कुछ इंस्टेंटेनियस होता, जस्ट इमेजिन व्हाट डिबैकल इट वुड हैव बीन. कि कहीं ब्लैक होल बैठा है, ठीक है, there are a bunch of black holes in the sky who are propagating instant interaction. So अभी बैठे बैठे मतलब all the black holes, they would have sucked each other in again instantly, because there is no speed limit. It would have sucked everything into itself. So to probably to create the world itself, it had to allow only a maximum speed limit. ठीक है?
Yeah, but one thing, but still correct. As per Einstein's prediction, you do have a the phenomena of the phenomena called where you can actually what's called spooky action at a distance.
At a
That is
distance, right? So that is
yeah.
quantum mechanics. It is
Hmm.
again an unsolvable thing in quantum mechanics.
Hmm. No, but they have done correct
It's good
done
you
some
reminded me
experiments.
of that. It's
Yeah.
good you reminded me of that. वो भी
Hmm.
फिर बाद में डिस्कस करेंगे. अभी
Hmm.
थोड़ा रिलेटिविटी चेक कर लेते हैं, फिर वहां पे
Hmm.
जाएंगे.
Hmm.
आई प्रॉमिस यू,
Hmm.
इट्स अ
Hmm.
गुड थिंग यू रिमाइंडेड मी ऑफ.
Hmm.
हाँ, तो अभी क्या हुआ कि नेचर ओनली अलाउज अ मैक्सिमम स्पीड लिमिट. ठीक है, फिर दूसरा इम्प्लीकेशन ये है कि इफ द speed of light is constant in every reference frame, it means that the reference frames are perceiving space and time differently, right? Because if c is the distance covered by light over the time spent on in the frame, in order to keep the c constant, you have to change these two quantities, राइट कि मेरे फ्रेम में लाइट ने जितना कवर किया प्रोबेबली, या फिर भूपेंद्र के फ्रेम में लाइट ने जितना कवर किया, इसका डिस्टेंस एंड द टाइम एज मेजर्ड बाय भूपेंद्र एंड अस एंड मी, they will be different so that the speed of light is the same. So इससे ये आ गया कि if you are moving with a speed, right, if you are moving reference or moving inertial reference frame, which means कि inertial मतलब moving with a constant velocity, ठीक है. If you are a moving reference frame, तुम्हारा क्लॉक थोड़ा स्लो हो जाएगा एंड यू विल बी रिकॉर्डिंग स्मॉलर डिस्टेंस. सो अगर एक रूम में है फॉर एग्जाम्पल हम दोनों, एंड भूपेंद्र स्टार्ट्स टू मूव, भूपेंद्र विल सी दैट द लेंथ ऑफ दिस रूम इज स्मॉलर and I will record the length of the this room as the some static length, right? And so Bhupendra will record the length of the room is smaller. Bhupendra will record कि यहाँ से वहाँ जाने के लिए भूपेंद्र का टाइम अगर T1 है, मेरे घड़ी में टाइम अगर T2 है, then T2 will be greater than T1. So जो स्टैटिक फ्रेम है इसमें ज्यादा टाइम बीतेगा, ठीक है. जो मूविंग रेफरेंस फ्रेम है उसमें टाइम थोड़ा स्लो चलेगा. सो न्यूटन ने जो अज्यूम किया था कि देयर इज एन यूनिवर्सल फ्लो ऑफ टाइम, दैट टिकिंग इज यूनिवर्सल, देयर इज एन यूनिवर्सल क्लॉक, प्रोबेबली सम सेलेस्टियल हेवनली क्लॉक व्हिच is ticking across the whole universe. Yeah, this is not true. Time is relative. It is a frame dependent description. The ticking is not universal. The ticking is also relative because it will tick fast if you are not moving. So similarly, let's say me and my twin, let's say Bhupendra and I, we are twins, right? So Bhupendra just go to space and then comes back. Bhupendra goes to, let's say, Proxima Centauri, which is four light year away, and then he comes back, and I am here with some specific speed. So Bhupendra will see कि I have become older. Bhupendra is younger. ठीक है. नाउ यू कैन आस्क मी कि भूपेंद्र के फ्रेम में मैं भी तो मूव कर रहा था, फिर मैं मेरा क्यों नहीं हुआ. बट दैट एक्चुअली डिपेंड ऑन द फैक्ट कि भूपेंद्र हैज गॉन थ्रू सम एक्सेलरेशन ऑन द वे एंड कमिंग बैक. वो थोड़ा उसमें जनरल रिलेटिविटी आ जाता है. बट इट इज अ फैक्ट कि जो मूविंग रेफरेंस फ्रेम है it will record it will record smaller amount of time, so the ticking will become slow. So now the time is neither universal not it is uniform. So it can depend. मतलब फॉर एग्जाम्पल कि मैं यहाँ बैठा हूँ, इसमें ग्रेविटी के वजह से जो टाइम का टिकिंग है, और फिर मैं माउंट एवरेस्ट में चला गया, वहाँ ग्रेविटी थोड़ा कम है तो वहाँ टिकिंग अलग होगा. ना दैट इज अगेन जनरल रिलेटिविटी. आई डोंट वांट टू गो देयर, but these are the things that we need to take care of while talking about time. So all this I have said to just to give you the idea that time is not an universal quantity, it is a relative quantity. यहाँ पे फिर नेक्स्ट जो फिजिक्स में जो क्वेश्चन पूछा जाता है, देयर आर ए सीक्वेंस ऑफ क्वेश्चन. जैसे भूपेंद्र ने जो क्वेश्चन उठाया दैट इज इन द रेलम ऑफ क्वांटम मैकेनिक्स, वो थोड़ा बाद में जाऊंगा. मैं एक ब्लैक होल के बारे में एक पॉइंट बता दूं. So now you know कि for example जब let's say me and Bhupendra we are together and we are watching a black hole from far away, and now I decided to go into the black hole. तो मैंने भूपेंद्र को बोला मैं अपना जो स्कूटी है स्कूटी लेके मैं जाता हूँ ब्लैक होल के अंदर, एंड आई विल सेंड यू सिग्नल इन रेगुलर इंटरवल एज पर माई फ्रेम. ठीक है. तो हर 1 मिनट बाद मेरे फ्रेम में, मुझे तो पता नहीं ना भूपेंद्र का क्या घड़ी दिखा रहा है, क्योंकि ब्लैक होल के पास ग्रेविटी का जो ग्रेडियंट है वो इतना ज्यादा होता है, मतलब थोड़ा सा जाने से ही वो टिकिंग का डिफरेंस आता है. सो मैंने बोला कि मैं अपने फ्रेम के हिसाब से आई विल कीप सेंडिंग यू ऑन रेगुलर टाइम इंटरवल. नाउ एज आई स्टार्ट गोइंग इनटू द ब्लैक होल, व्हाट भूपेंद्र विल सी कि बिजित एक्चुअली चीट कर रहा है. बिजित मुझे रेगुलर इंटरवल में सिग्नल नहीं भेज रहा है. तो तो विजित जब जाना चालू किया था तब 1 मिनट बाद भेजा था एग्रीड, बट फिर वो धीरे धीरे 1.1 मिनट हुआ, 1.2 मिनट हुआ, फिर 2 मिनट हुआ, अब विजित मुझे 10 मिनट बाद भेज रहा है. नाउ ही इज सेंडिंग आफ्टर 20 मिनट्स, एंड देन 1 साल हो गया अभी तक कुछ नहीं भेजा. भूपेंद्र इज फाइनली सीइंग कि विजित इज नॉट सेंडिंग मी एनी सिग्नल एट ऑल. ठीक है. अब ये हो क्या रहा है, मैं मेरे घड़ी के हिसाब से मैं भूपेंद्र को 1 1 मिनट बाद भेज रहा हूँ, आई एम बीइंग लॉयल टू इट. बट ये जो मतलब मैं तो जब घुस रहा हूँ, माई फ्रेम इज कॉन्स्टेंटली चेंजिंग बिकॉज ऑफ द ह्यूज ग्रेविटी ऑफ द ब्लैक होल. ठीक है. तो मैं जैसे ब्लैक होल के इवेंट होराइजन के पास चला गया जहां से मैं कभी लौट नहीं सकता. वहां से मैं भूपेंद्र को अगर सिग्नल भेजूं, दैट विल नेवर रीच. क्योंकि क्या हो रहा है इफेक्टिवली, ग्रेविटी इतना ज्यादा है, वो लाइट को जैसे स्ट्रेच कर देता, मतलब एज इफ मैं अगर ब्लू लाइट भेज रहा हूँ, ठीक है, उसका जो वेवलेंथ है वो स्ट्रेच हो जाता है बिकॉज स्पेस एंड टाइम आर रिलेटिव, राइट. एंड ब्लैक होल इतना बेंड कर देता है स्पेस टाइम को कि मैं अगर ब्लू लाइट भेजता हूँ जिसका फ्रीक्वेंसी बहुत ज्यादा है, जिसका वेवलेंथ बहुत छोटा है, वो भूपेंद्र तक पहुंचते पहुंचते वो डाइल्यूट हो रहा है, वो रेड बन रहा है पहली बात, और टाइम भी चेंज हो रहा है. मतलब मेरे फ्रेम में अगर कोई 1 मिनट है, वो भूपेंद्र के टाइम में इटर्निटी होगा. इनफैक्ट भूपेंद्र इफ ही गेट्स टू सी, मतलब ही विल इंटरप्रेट कि विजित भेज नहीं रहा है. अगर विजित लॉयल है अंदर से, तो विजित का जो वॉच है वो फ्रीज हो गया है. सो दैट विल बी द इंटरप्रिटेशन ऑफ भूपेंद्र कि विजित इज नॉट परसीविंग टाइम एट ऑल बिकॉज भूपेंद्र हैज ट्रस्ट इन मी. सो ही विल से कि विजित का टाइम फ्रोजन है, दैट्स व्हाई ही इज नॉट सेंडिंग एनी सिग्नल. ये भूपेंद्र का इंटरप्रिटेशन रहेगा. Now, yeah, so this is actually saying something very important, which is also related to the fact कि when you start to move at the speed of light, फिर टाइम फ्रीज करने लगता है. मतलब यू पार्सिव, मैंने बोला ना कि भूपेंद्र अगर प्रोक्सिमा सेंटावरी तक गया फिर वापस आया, वो जवान रहेगा, मैं बूढ़ा हो जाऊंगा. सो basically when you start to move at the speed of light, near the speed of light, at the speed of light, time gets frozen. Now this is another anomaly, right? Matlab, you will say कि if there is a free electron at all, जो बिग बैंग से पहले से, या if there is a free scalar particle at all which is massless moving at the speed of light, it does not know anything about the past and it will never know anything about the future because time is frozen in its own reference frame and it does not perceive time. ठीक है. तो फिर ऐसे रेफरेंस फ्रेम में, ऐसे सिचुएशंस में, हाउ कैन यू डिफाइन टाइम एट ऑल, जहां पे लिटरली टाइम गेट्स फ्रोजन. दे आर, मतलब इन दोज केसेस, इन दोज सिनेरियो, इज टाइम अंडरलाइंग वेरिएबल एट ऑल? दिस इज एन ओपन क्वेश्चन, राइट. इसको अप्रोच करने का अलग अलग उपाय है. मतलब मैं जिस तरह से देखता हूँ वो शायद लोगों से अलग हो सकता है. मैं देखता हूँ कि ठीक है, व्हाट इज टाइम? टाइम इज ड्यूअल टू मूवमेंट. इफ देयर इज नो मूवमेंट, at least as recorded by you, if if you're a, let's say, lonely particle, you're a sole particle, point particle in an universe, um, and you are there, I mean, you cannot say ki whether you are moving at all, right? If you are moving at a uniform speed, or say you are static in an infinite universe, it does not make sense. You cannot say कि भाई मैं move कर रहा हूँ uniform velocity से, या फिर I am standing static, right? Because you are the only particle in the universe. There is no reference with respect to which you can discuss the motion. Now, जब motion का idea जब ऐसे ये हो जाता है, when the idea of motion gets redundant, then the idea of time should also get redundant. Why? Because time is dual to movement. Time is dual to motion. If there is no existence of motion, there is no existence of movement, then there is no existence of time itself. By that I mean कि if you try to write some physical equation about that single particle in an otherwise infinite lonely universe, you are not going to, you don't need time as a parameter, time as a variable to describe your state, your motion, or anything, then time becomes a redundant idea. Just like if there is the universe is completely static, then there is no idea of time as per me. तो उस हिसाब से फिजिक्स को ले जाना होगा जहाँ पे वी हैव टू स्टार्ट अंडरस्टैंडिंग कि मोशन के साथ क्या होता है नियर द ब्लैक होल लेट्स से। इसमें फिर और एक कॉम्प्लेक्सिटी आ जाता है। अभी तक जो मैंने बताया दोज आर नॉन क्वांटम मैकेनिकल, बट फिर क्वांटम मैकेनिकल फेनोमेना आ जाता है जो एक्चुअली थोड़ा और वियर्ड बना देता है ये सारी चीजों को। फॉर एग्जाम्पल राइट द I mean, this is called Lipier paradox, Einstein Podolsky Rosen paradox. तो आइंस्टाइन ने एक्चुअली क्वांटम मैकेनिक्स को मान नहीं पाया वो। It is because of those uncertainty principles. And then he came out with something. Now, what is uncertainty principle? Uncertainty principle actually ये बोलता है in no point you can definitely say what is the position and momentum of a particle or of a state. मतलब जैसे मैं अभी बैठा हूँ, so classically you can say कि Bijit's velocity is 0 and Bijit is in XYZ position. But quantum mechanics उसको इनकार कर देता है कि if you are specifying the position, the information about momentum is completely lost. मतलब the error bar when you define a momentum is actually infinite. So position and momentum cannot be simultaneously sort of calculated or predicted, and it actually lead to a consequence जहाँ पे हम लोग बोलते हैं कि क्वांटम मतलब एज यू गो डीप डाउन टू लेट्स से नैनो स्केल 10⁻⁹ और 10⁻14 जहाँ पे न्यूक्लियस बैठा हुआ है, then there is no particle, neither there is any wave, right? There are only quantum mechanical states जिनका पोजीशन मोमेंटम तो हम लोग डिटरमाइन नहीं कर सकते हैं, बट उनका एक्सपेक्टेशन वैल्यू बता सकते हैं कि अच्छा ठीक है ऑन एवरेज इट इज सिटिंग एट दैट प्लेस।
Okay, just one thing. So the state would mean in Hindi dasha,
अवस्था अवस्था
avastha or dasha,
नहीं,
because
दशा
the
इज फेज,
transit.
दशा इज फेज।
Okay, dasha is phase. Okay.
हाँ,
So when we
अवस्था
call when we call phase transition, so you are changing from one state to another. So that's why I thought.
वन दशा टू अनदर।
So correct, phase transition में correct is change of state, correct?
फेज ट्रांजिशन इज चेंज ऑफ फेज।
Yeah,
उसको
but phase.
प्रॉपर्ली स्टेट कहा जाता है। स्टेट इज लाइक
Hmm,
जब तुम व्हेन यू आर गोइंग लाइक इनटू द माइक्रो डिस्क्रिप्शन ऑफ अ फेज,
hmm,
जैसे वाटर,
hmm,
वाटर इज अ फेज, आइस इज अ फेज,
hmm,
बट वाटर मॉलिक्यूल और द
hmm,
क्रिस्टल ऑफ आइस
hmm,
दोनों H2O है। सो H2O इज सम एटॉमिक स्टेट, बट जैसे एक H2O दूसरे से कैसे जुड़ा हुआ है, वो जो लिंक क्या है, और
hmm,
उसको जब
hmm,
बड़े मतलब व्हेन यू आर थिंकिंग मैक्रो साइज दैट बिकम्स अ
hmm.
फेज। Like
Correct. Yeah.
ice melting into water is a phase transition,
Hmm,
and
hmm,
it is
hmm,
obviously a change of the states as well.
hmm, hmm,
But it is the interactive states that are changing because H2O is not changing. H2O is pretty much as it is, but
hmm,
the
hmm.
way one H2O is interacting with another H2O, that is changing. That's why the phase is changing.
Yeah, because these are a little bit abstract concepts, and
No, phase is
right.
what? Phase is, let's say, so in the context of this podcast, right?
Hmm,
So if we move from the description of, let's say, this time to description of, I don't know, some random political event like we do, it is a phase transition of the podcast. But if you, let's say, I get replaced, you replace me with someone else sitting here right now, then it is the change of state. So the podcast is a phase, and me sitting here is so obviously when the state changes, there will be a phase transition, but we don't call it phase transition because phase is a sort of a macro description of something. Ice is a phase, right? Water is a phase. So one phase transiting into another is phase transition, and transition of state is like uh, स्टेट मतलब हाँ H2O is dissociated into hydrogen and oxygen. It is a transition of state itself. मतलब atomic state का transition हुआ. The state changed from H2O to H2 and O2. That's how I perceive it. Probably yeah. मतलब phase is a physical transition and state transition is probably some sort of a chemical transition, I would say.
Yes.
But I agree what you are saying कि मतलब उस तरह you can define it that way. हाँ तो स्टेट जैसे बोल रहे थे कि हाँ in quantum mechanical world where it is let's say the size is less than 10 to the power 9 10 to the power 10 तब क्या होता है you cannot say whether something is a particle or a wave but it exists as a state. Okay. उसे क्वांटम मैकेनिकल स्टेट बोलो, कुछ लोग बोलते हैं दिस इज वेविकल, अलग अलग नाम देते हैं. बट अगेन कुछ लोग बोलते हैं कि इट इज बोथ पार्टिकल एंड वेव, विच इज स्लॉपीली अगेन ट्रू. बट दिस थिंग इन इटसेल्फ मतलब तुम तभी बता सकते हो इट इज पार्टिकल और वेव व्हेन यू आर मेकिंग एन ऑब्जर्वेशन. ठीक है. When you are not making an observation, you are not even allowed to say well, this is both particle and wave. So, for example, ये कहाँ से आया, ये इसके इसके पीछे काफी एक्सपेरिमेंट्स है. सो फॉर एग्जांपल देयर इज अ एक्सपेरिमेंट कॉल्ड डिवीजन गार्मर एक्सपेरिमेंट. ठीक है. डिवीजन गार्मर एक्सपेरिमेंट में व्हाट दे डिड, सो देयर वाज दिस गाय थॉमसन फ्रॉम आई थिंक कैवेंडिश लैब इन कैम्ब्रिज. he discovered electron in 1899 I guess. And he said कि I have discovered a particle. It has this much charge. This particle is named electron. ठीक है. फिर डिवीजन गार्मर ने दिखाया अच्छा इलेक्ट्रॉन पार्टिकल है बट समथिंग वियर्ड हैपेंस कि अगर तुम छोटा सा एक स्लिट ले लो, दिस स्लिट इज लेट्स से ऑफ द साइज ऑफ 10 टू द पावर -6 -7, उसी रेंज में है. ये तो लाइट का रेंज है, 10 टू -8 उस रेंज पे है. ठीक है. उस स्लिट के थ्रू अगर तुम यू स्टार्ट थ्रोइंग इलेक्ट्रॉन्स तो उसका एक्चुअली डिफ्रैक्शन पैटर्न बनता है. नाउ डिफ्रैक्शन इज अ वेव प्रॉपर्टी. Electron is a particle. You are throwing electrons through the slit. It should just pass through that slit, right? If this is a slit, the electron should just pass through it and just project onto a single sort of line. But then it is not a line. There are diffraction patterns. So how is it possible for a particle to make diffraction pattern? ये हो गया. फिर अलग आइडिया है जैसे जब नील्स बोर जब एक पोस्टुलेट लेके आया जिसमें ही प्रेडिक्टेड कि यू नो इलेक्ट्रॉन्स आर वियर्ड बिकॉज इलेक्ट्रॉन्स ओनली हैव डेफिनिट ऑर्बिटल्स अराउंड एन एटम. Electron cannot occupy orbitals of arbitrary radius, but the radius is actually determined by their mass and obviously the mass of the nucleus to which it is bound with. So the radius of orbital is specific and it cannot be arbitrary radius. So it is just like कि electrons are forming stationary waves. जैसे कैसे दिखाऊं कि
What
you know हम
what
stationary, हाँ वो नहीं स्टेशनरी वेव ऐसे होता है जैसे फ्लूट के अंदर होता है. फ्लूट के अंदर हो गया कि या फिर जब गिटार बजाते हो इट फॉर्म्स अ स्टेशनरी वेव. वेल कंप्लीट नॉट कंप्लीटली स्टेशनरी बिकॉज स्टेशनरी वेव मींस कि इट स्टोर्स द एनर्जी. एनर्जी प्रोपगेट नहीं हो पाता है. सो अगर दो मान लो दीवार है उसके बीच कोई यू टाई अ थ्रेड एंड यू डिस्टर्ब इट, द थ्रेड विल फॉर्म अ स्टेशनरी वेव. Because why? Because it is not propagating any energy. The thread is not infinite. It is just stuck there. It is just randomly, not randomly, but it is harmonically oscillating. ठीक है. तो इलेक्ट्रॉन का भी वही होता है कि इलेक्ट्रॉन तब तक उसी ऑर्बिटल में रहेगा जहां जहां इलेक्ट्रॉन को अगर थ्रेड की तरह सोचा जाए, wherever it will be able to form stationary wave with the de Broglie wavelength. मतलब उसका जो उसका अगर कुछ मास है उसके हिसाब से एक इक्विवेलेंट वेवलेंथ होगा जो de Broglie वेवलेंथ कहा जाता है. वो de Broglie वेवलेंथ जब स्टेशनरी वेव फॉर्म करेगा उसी ऑर्बिटल में इलेक्ट्रॉन स्टेशनरी रहेगा. सो ओनली some orbitals are allowed and not arbitrary orbitals are allowed for stationary electron in a nucleus. ये एक आ गया. So these were showing कि electrons in some way they are behaving like these particles, like sorry, electron are behaving like waves. ठीक है. तो फिर वहां से ये क्वांटम मैकेनिक्स आया जहां पे बोला कि इलेक्ट्रॉन is a quantum mechanical state. It is neither a particle, it is not a wave, but it is some quantum mechanical state. Obviously, if you try to project it to the, so now I'm talking a little bit of mathematics here. So it is a quantum mechanical state. Let's call it a psi. Okay, let's denote it by psi, a Greek letter psi. And if you project it into the position space, right, which means ki if you try to find its position, okay, it will show it some position. But rather than finding position, if you try to find its momentum, if you try to project it to a momentum state, it will give you some momentum. It will show you it has some momentum, which is a sort of a wave property. But you cannot simultaneously specify the position and the momentum. Either you have to project it to a momentum space or you have to project it to a position space to find out the momentum or the position. But you cannot perform these two operators simultaneously because in the mathematical terms, these two operators, the momentum operator and the position operator, they do not commute. Okay, they are not exchangeable. Because they are not exchangeable, you cannot perform these two simultaneously without altering the other. Okay, you cannot measure position without altering the momentum, and you cannot measure momentum without altering the position. So this is the quantum mechanics. यहाँ पे एक पंगा ऐसा आया कि okay, so everything is fine, but in quantum mechanics there is a thing called entanglement. Okay, तो ये जो मैंने साई बताया, ये जो स्टेट क्वांटम मैकेनिकल स्टेट बताया. Now, ठीक है, for one electron you can write a quantum mechanical state. Similarly, if you have two electrons, two interacting electrons, okay, let's say two electrons of helium. Yeah, right. So I'm bad at chemistry. That's why I'm just trying to remember the atomic number of helium, which is two. But okay, I know that much chemistry. So, take for example helium. Helium has two electrons, and इलेक्ट्रॉन का स्पिन होता है. ठीक है. स्लॉपीली सेइंग कि कैसे बताऊं, इलेक्ट्रॉन का एक एक्स्ट्रा क्वांटम मैकेनिकल नंबर होता है जिसको स्लॉपीली सोचा जा सकता है कि एक इलेक्ट्रॉन इस तरह घूम रहा है और दूसरा इलेक्ट्रॉन दूसरी तरह घूम रहा है, बिकॉज दे आर direction of rotation in the classical sense is different. Again, this is a classical equivalent description of something quantum mechanical, but analogies are never correct, but they give you sense of something important. So that's why I'm using an analogy कि दो इलेक्ट्रॉन ऐसे घूम रहा है, एक का तो ठीक है, एक का एक्सिस रोटेशन मतलब डायरेक्शन ऑफ रोटेशन इज अप, अनदर दूसरे का मतलब direction of rotation is down. So up and down, and they are entangled. So एक इलेक्ट्रॉन के लिए जैसे इक्वेशन ऑफ स्टेट लिखा जाता था, वैसे दो इलेक्ट्रॉन है हीलियम में, उनके लिए भी एक सिंगल इक्वेशन ऑफ स्टेट यू कैन राइट डाउन. ठीक है, which will be psi of x1 and x2 and p1 and p2, right? Psi of 1 and 2, so to say. You don't even need x1 and p1. Psi of 1 and 2, which is the psi, the quantum mechanical state of the both the electrons together. यहाँ पे पंगा क्या आता है कि ये जो फर्स्ट इलेक्ट्रॉन एंड सेकेंड इलेक्ट्रॉन है, ये दोनों इंटेंगल्ड है, विच मीन्स कि कैसे बताएं कि एक इलेक्ट्रॉन को अगर इसके स्पिन के बारे में तुम्हें पता चला विदाउट डूइंग एनी एक्सपेरिमेंट ऑन द सेकेंड इलेक्ट्रॉन, यू कैन इंस्टेंटली गेस द स्पिन प्रॉपर्टीज ऑफ द सेकेंड इलेक्ट्रॉन. मतलब एक इलेक्ट्रॉन अगर अप स्पिन है तो उसका अप स्पिन उसको तुम एक स्टार्न गार्लक एक उसका मशीन होता है, उस एक्सपेरिमेंट होता है, उसमें डालो, उसका स्पिन अप निकल गया. फिर दूसरे का विदाउट डूइंग एनी एक्सपेरिमेंट ऑन द सेकंड वन यू कैन से इट इज स्पिन डाउन. आइंस्टाइन ने ये जो लॉजिक है इसको थोड़ा और एक्सटेंड किया.
Okay,
आइंस्टाइन ने
just one interjection. Sorry. So with your narration, people might think a electron spins physically in that way. It doesn't. It's a
नहीं
conceptual
मैंने
thing
बोला
which is
कि एनालॉजीज आर नेवर करेक्ट, but
हाँ
nevertheless it gives you a understanding of what is going on. So I mean it gives you some equivalence. अभी स्पिन बोलेंगे तो थोड़ा फिर रिलेटिविटी में जाना पड़ेगा. आई
they
डोंट
will
वांट टू गो
spin
बैक टू रिलेटिविटी.
they will think of spin bowling, so that's why I thought this is
नहीं
is
नहीं, so
clear.
spin is right. So spin is related to angular momentum. So that's why I'm saying, that's why I'm using that description कि इस तरह और उस तरह, because spin is actually related to angular momentum. What you do is कि with the orbital angular momentum you add some amount of spin to electron to write down the angular momentum of an electron. तो उस हिसाब से इट इज अ स्लॉपी डिस्क्रिप्शन, बट नेवरदलेस इट इज एन इम्पोर्टेंट सॉर्ट ऑफ एनालॉजी कि एक का स्पिन अप है, मतलब वो ऐसे घूम रहा है, और दूसरा दूसरी तरफ घूम रहा है. ठीक है, स्लॉपीली सेइंग दिस इज द एनालॉजी. हाँ. तो मैं कहा था फिर. हाँ, तो आइंस्टाइन ने इसको एक्सटेंड किया कि ठीक है, दो इलेक्ट्रॉन है मान लो हीलियम का, एंड दोनों इंटेंगल्ड है. ठीक है, तो एक इलेक्ट्रॉन को, मतलब दोनों इंटेंगल्ड है, फिर एक काम करते हैं, because this is a quantum mechanical state, and at that level of quantum mechanical state we are not even talking about position or momentum. We are not interested in doing an experiment to find out the position or momentum of any of the two. तो ये दो पार्टिकल है, मैं कुछ नहीं करूंगा, मैं कोई ऑब्जर्वेशन नहीं करूंगा. व्हाट वी आर गोइंग टू डू, वी आर गोइंग टू टेक वन इलेक्ट्रॉन, और उसको मैं हम लोग जाके प्रॉक्सिमा सेंटाउरी पे रख देंगे, और एक इलेक्ट्रॉन को यहाँ अर्थ पे रखेंगे. मतलब जस्ट टेक इट अपार्ट. ठीक है, एंटेंगलमेंट हो गया, फिर उसको दूर ले जाके दूसरे मतलब नियरेस्ट जो स्टार है वहां छोड़ दो. फिर क्या करो, फिर ये जो इलेक्ट्रॉन हमारे पास है इसका स्पिन निकालो. इसका स्पिन निकाल के देखा कि अच्छा ये तो अप स्पिन है, ये ऐसे घूम रहा है. एक्चुअली क्या हो, राइट हैंड रूल के मतलब अप स्पिन है तो ऐसे घूम रहा है, राइट. तो फिर इंस्टेंटली हम लोग बता सकते हैं कि जो दूसरा इलेक्ट्रॉन था उसका जो स्पिन था वो डाउन था, वो ऐसे घूम रहा था. एंड इट डज नॉट डिपेंड कि हाउ फार दे आर, बिकॉज दे आर एंटेंगल्ड वी कैन मेक एन इंस्टेंटेनियस क्लेम कि दूसरे का स्पिन डाउन है अगर इसका स्पिन अप. नाउ दिस इज इन वायोलेशन ऑफ द प्रिंसिपल ऑफ रिलेटिविटी, क्योंकि आई जस्ट टोल्ड यू कि नथिंग कैन ट्रेवल एज फास्ट एज लाइट. लाइट के, और नथिंग कैन ट्रेवल फास्टर देन लाइट फॉर एग्जाम्पल. तो द but we are making some instant sort of conclusion about the state of the other particle without even knowing what is going on there. And with 100% accuracy, if you perform the experiment you will see कि this is right. इसका मीनिंग क्या है कि मैंने अपना जो आप वाला इधर रखा, भूपेंद्र को मैं प्रॉक्सिमा सेंटाउरी पे भेजा, मैंने यहाँ एक्सपेरिमेंट परफॉर्म किया, भूपेंद्र का वॉच था तो उन्होंने कर दिया. फिर मैंने मेरा लिखा कि मेरा वाला आप है तो भूपेंद्र का डाउन है. भूपेंद्र का 4 साल बाद आ रहा है और भूपेंद्र विथ 100% एक्यूरेसी विथ माई प्रेडिक्शन भूपेंद्र बता रहे हैं हाँ तो इसका डाउन है. ऐसे जितने भी पार्टिकल के साथ करो, इंटेंगल पार्टिकल के साथ विथ 100% एक्यूरेसी ये मेरा मैच कर जाएगा. सो I'm predicting the dynamics of a particle that Bhupendra has without even performing an experiment on it, and I am predicting it instantaneously. This is a paradox क्योंकि this is in violation with relativity, this is in violation with causality. क्यों, क्योंकि यहाँ पे मैं कुछ प्रेडिक्ट कर रहा हूँ, मतलब without knowing the information from Bhupendra I am predicting something. So in a way this is the cause is the effect is preceding the cause. ठीक है, तो it is
Okay,
in violation.
just one thing here. So, in that way, are we like correct in any kind of equation that is written in physics? Correct. Time has to be there as a kind of constant to actually make sense of it, because
Not
we make
constant, as a variable, as a variable.
yeah. Sorry. As a variable. So I'm talking about this one, Einstein one. So as a variable, it is there actually to make sense of our world around. So all our senses, okay, all our understanding of prakriti is dependent on the time that we are measuring it, and time when we will give a reference to time to actually explain that thing. In that
Right.
way, are we in this entangled particles, is time being negated as a kind of a
Exactly.
variable.
Exactly, right. Where is the time coming here? I mean, almost instantly I am predicting the about the state of that particle without interacting with it. Where in quantum mechanics, whenever you make an observation, you perturb the state of that very particle on which you are making the observation. But here I am not even perturbing the state of the particle about which I am doing the observation. मतलब ठीक है मेरा वाला particle में मैंने कर लिया. But am I actually perturbing the other particle which is sitting in the proximal interview with you? यहाँ पे फिर इसको ये आइंस्टाइन ने पेपर पब्लिश किया इसको ईपीआर पैराडॉक्स कहा जाता है आई थिंक 1933 फिर आइंस्टाइन ने एक दूसरा पेपर पब्लिश किया इन स्पेशल रिलेटिविटी ही डिड नॉट से एक्सप्लिसिटली वो पेपर किस लिए था सो द फर्स्ट पेपर वाज ईपीआर आइंस्टाइन पोडल्स्की एंड रोजेन the second paper is with of Einstein and Rosen. Rosen was a student at that time in Princeton Institute of Advanced Study. फिर आइंस्टाइन एंड रोजन ने एक पेपर निकाला उसमें उन्होंने सॉर्ट ऑफ एक ब्रिज का कॉन्सेप्ट दिया एक वार्म होल का कॉन्सेप्ट दिया ठीक है तो I wish I could show you the geometry of it, but I don't have any book now. But how to? Huh? I think I have a way to show it actually. चलो try करते हैं. हाँ. So this is ठीक है इसको थोड़ा फनल की तरह इमेजिन करो और दूसरा ये है इसका भी खुला हुआ है इधर विटामिन डी है तो इसको भी फनल इमेजिन करो ठीक है नाउ यू इधर इधर हाँ इसका इस तरफ ओपन है तो ये एक फनल है जैसे ये भी नीचे से एक फनल है और इन दोनों को कनेक्ट कर दो तो ये इधर से खुला हुआ है ये इधर से फनल है और बीच में क्या हो रहा है शायद हमें नहीं पता और दिस इज बियॉन्ड आवर 4 dimensional स्पेस टाइम दिस इज सम सॉर्ट ऑफ अ ब्रिज जो यूनिवर्स के दो कॉर्नर को मतलब मैं अर्थ पे बैठा हूँ भूपेंद्र अपने प्रॉक्सिमा सेंटाउरी पे बैठा है इसको
So
बियॉन्ड
yeah.
4 dimensional स्पेस टाइम वो भी मैं दिखा रहा हूँ वो भी दिखा रहा हूँ पहले ये कर देता हूँ
Mm-hmm. Mm-hmm.
तो यहाँ पे दो पार्टिकल है एंड दे आर नाउ कनेक्टेड थ्रू दिस ब्रिज तो आइंस्टाइन ने पे एक पेपर इन्होंने कुछ बताया नहीं मतलब दे जस्ट इमेजिन दिस एंड दे परफॉर्म द कैलकुलेशन अभी बताया जा रहा है कि मे बी दिस entangled particles are connected through this Einstein Rosen bridge इसका नाम भी इस वर्म होल का रख दिया गया है इसको ER ब्रिज कहा जाता है और ये जो पोस्टुलेट है इसको बोला जाता है ER equals EPR तो ये बोला जाता है कि ये जो ईपीआर फिनोमेना है दिस इज अ मैनिफेस्टेशन ऑफ द ईआर फिनोमेना जहाँ पे एक्चुअली क्या हो रहा है हाँ पेपर अगर है तो दिखा सकते हैं राइट
Yeah, yeah. You
अब
can show that
तो जैसे ये
this one.
हाँ
Yeah. Mm.
बड़ा पेपर है क्या राइट मैं घड़ी से
So
दिखा सकता हूँ तो दिस इज
yeah, yeah, yeah,
लेट्स
yeah. Mm.
लेट्स से these are the two remote corners like Bhupendra sitting here I am sitting here तो क्लासिकली जो स्पेस टाइम दिख रहा है उसमें तो यहाँ से लेके यहाँ तक जाना पड़ेगा विच विल टेक सम टाइम बट मे बी इन सम एक्स्ट्रा डिमेंशन दे आर जस्ट कनेक्टेड लाइक दिस जिसमें दिस इज थ्रू एन एक्स्ट्रा डिमेंशन तो इसलिए दिस इज एन सो नाउ इट इज एन एक्स्ट्रा स्पेस डिमेंशन तो इसलिए इंस्टेंट प्रोपगेशन पॉसिबल हो रहा है सो प्रोबेबली जो क्वांटम मैकेनिकल जो एंटेंगलमेंट है this is actually manifestation of something deeper कि there exist extra dimensions beyond our 3 dimensional space and 1 dimensional time तो वहां पे थोड़ा और इंटरेस्टिंग हो जाता है शायद टाइम फिर भी बच जाता है बट टाइम भाग लेता है खुद को बचा लेता है बट स्पेस कैन नॉट मतलब स्पेस probably needs to accept another dimension in order to explain that phenomena. And this is still an open question, but it is a paradox in classical canonical quantum mechanics. Let's put it that way.
And yeah, and one more thing. So in terms of the what we have as of now, correct? The Big Bang theory, correct? The Big Bang theory actually predicts that time comes into existence when Big Bang happens. Okay.
Right,
Only then you'll be able to actually measure it because
right.
the
I
Big
mean,
Bang.
it again matches with my sort of the postulate that I'm telling. Ki
Mm, mm.
time is dual to movement.
Hmm.
If you don't have the movement, मतलब black hole के
Hmm.
उस time पे जब
Hmm.
singularity था, you
Hmm.
did
Hmm.
not have a definition of movement. You did not have a thing that was moving probably. Then obviously movement was frozen. So that's why
Hmm.
time was frozen as well. And if time is frozen, it is a redundant quantity. And in physics, we don't introduce redundant parameters or variables in our equations. So when time becomes redundant, it becomes a non-entity from the perspective of a physicist. Like for
Exactly.
example, what is space? Space become redundant if everything is uniform. Like because you are sitting there, I'm sitting here, we have a specific matter density around us which is different from our surrounding. That's why we are defining this, we are creating the idea of space. If everything is made of iron, then the idea of space is not there at all, right? Space is dual to the extent of matter or extent of something, extent of a state. If that extent is not there, then the idea of space become redundant and it becomes a non-physical entity from the perspective of a physicist. I mean,
Yeah.
you can still
Okay.
introduce it in the equation, but it will just cancel out.
Can you do one thing? If you can you just give a explain about Hilbert space? The Hilbert space, uh, it's little bit
Right.
complicated, but yeah.
हाँ, so physically से समझा देता हूँ कि कहाँ से आ
Hmm.
रहा है.
Hmm. Hmm.
तो हाँ, जैसे हिल्बर्ट स्पेस का ये सीन है कि मैंने बताया था कि ओके, सो आई टोल्ड यू कि नियर 10⁻⁹, 10⁻⁻10 और 10⁻14 15 मीटर जहाँ पे न्यूक्लियस बैठा हुआ है. यहाँ पे क्या होता है? सो आई टोल्ड यू कि these things, the nucleus, it is neither particle nor wave. It is a quantum mechanical state. Uh, and you can project this onto the position space or the momentum space to find out the position and momentum of nucleus. Right. जब मैं बोल रहा हूँ कि you can project it onto the position space, it inherently means कि the state that I'm talking about, it is beyond the position space. That's why you need to project it. So this state is living in some space which is probably beyond our position space and our momentum space. What space is that? It is an abstract space. And some of the properties that we have defined, for example, number of, if you want to measure the number of nucleus for one nucleus, it will always give you one. You don't need to always project it to the position space and then go back to the this abstract space that I'm talking about in order to count the number. Right? In order to count the number, you're just going to deal within that abstract space in which this quantum mechanical state is living. What space is that? That is the Hilbert space. ठीक है? And it obeys trivial things like if there is one nucleus here and one another nucleus here, the total number is two. So the sort of the typical linear algebra things that we have constructed in terms of the norm, or in terms of, yeah, the number, those are actually, those can be done within that space only. उसके लिए position space पे project करके नीचे आना नहीं पड़ेगा. That is the Hilbert space. फिर Hilbert space से when you are trying to make observations, you bring that state, you project that state to a momentum or position space, and then you calculate, let's say, where is it sitting, what is the probability within that much volume of a box. So that's why these quantum mechanical states, they are living in some abstract space which obey by linear algebra, like linear superposition of things and all. Again, superposition is it is a position space thing, so avoid that. But
Hmm.
it obeys typical linear addition, multiplication by scalar, and it is actually the space of those quantum mechanical state, which is the Hilbert space. So that's why when you're talking about Big Bang, right? In physics, you can do many calculations in some. Well, it is. See, in physics, when you're talking about Big Bang, is यहाँ पे जवाब नहीं मिल रहा है, solve नहीं कर पा रहे हैं. It is not because कि not only because the idea of space and time are doomed there, it is also because of the fact कि हमें स्पेस टाइम अगर इग्नोर भी करके हम हिल्बर्ट स्पेस पे कैलकुलेशन करते हैं, वहां पे भी हमें इंफिनिटीज मिलता है. सो फॉर एग्जांपल व्हेन आई से कि अच्छा यू हैव अ लेट्स से न्यूक्लियस, ठीक है, अपर से नहीं नहीं अपर की बात नहीं है, जस्ट इमेजिन अ लिटिल बिट, मतलब आई विश आई हैड अ बोर्ड देन इट वुड हैव बीन इजियर. But let's say you have one nucleus and you want to see its property near Big Bang, and let's say it has not interacted with anything since Big Bang. It was created during some time after Big Bang. इसको अगर प्रोजेक्ट करते हो, इफ यू प्रोजेक्ट बैक टू द टाइम ऑफ क्रिएशन, यू विल सी कि जैसे बोल रहा हूँ कि ट्रिवियली एक न्यूक्लियस होना चाहिए, बट वो जो प्रॉपर्टी है ये वो खोने लगता है बेसिकली. द नंबर इज नॉट कंजर्व्ड, ठीक है, यू हैव टू add other things in order to keep this non conserved and all these things कि एक न्यूक्लियस था बिग बैंग के टाइम पे, ये स्टेटमेंट भी नहीं दे सकते. दिस इज अ दिस इज एनोमली इन द, मतलब जो हिल्बर्ट स्पेस पे कैलकुलेशन करके भी ये एनोमली आ रहा है. वी डोंट इवन नीड टू प्रोजेक्ट इट टू अ position space, and that's why this is a real anomaly. मतलब फिजिक्स
Yeah,
डू हैव डिस्क्रिप्शंस व्हिच आर बियॉन्ड. अभी एक मॉडल आया है जो नीमा आरकानी, हमें एक इरानियन फिजिसिस्ट है. ही केम अप विद समथिंग कॉल्ड एम्पलीट्यूड हेड्रॉन. It's like the typical octahedron structure, but it is not in the typical position space that we imagine. Because हमें पता है कि the way we perceive space and time, it is not going to be the same around the time of creation. तो उस हिसाब से वो लोग अलग से काम कर रहे हैं कि लेट्स डिस्कार्ड द आइडिया ऑफ स्पेस एंड टाइम, द कैनोनिकल स्पेस एंड टाइम, and create new space in which we add on all these quantum mechanical states, and from how they interact by using different principles. ठीक है, जो क्वांटम मैकेनिकल प्रिंसिपल्स है कि कॉजलिटी थोड़ा लगाते हैं, यूनिटरी प्रिंसिपल लगाते हैं. यूनिटरी प्रिंसिपल मतलब अगर आज एक ही न्यूक्लियस था, वो 2 दिन बाद एक न्यूक्लियस ही रहेगा, मतलब सच टिपिकल ट्रिवियल नोशन लगा के लेट्स फाइंड आउट कि स्पेस कैसे इमर्ज करता है. देयर आर अदर थियोरीज एज वेल, मतलब ऑब्वियसली स्ट्रिंग थियोरी है, बट स्ट्रिंग थियोरी में तो स्पेस टाइम है. um,
yeah.
फिर
So it is very important. So, like, just to actually keep the audience little bit abreast on this.
राइट
So why? Okay, so people would ask, okay, why we are talking about cosmology, Big Bang, and other things when we are talking about time?
राइट
Why we are spending this 1.5 hours talking about all the other thing is that everything exists because we have a concept of time, which actually gives like kind of legitimacy to whatever exists.
राइट
If you remove time from in as a variable, okay, that everything that we are able to describe from Big Bang to space to Hilbert space, nothing will be definable if we remove time as a variable. So now the thing is, if I am going to tell you, or we are going to tell you that okay, time is very important, they will say how it is important. So we have this 1.5 hours of discussion to tell you this at the end, that without the concept of time and time as a variable to actually describe the prakriti around you from creation to destruction, nothing actually exists as it's defined now. Okay, so that's how important time is. And the most paradox, the biggest paradox is that still people do not agree what exactly is time. We
We
know
don't know
that
what is time. Right.
we don't know how to define it actually. There are people who vehemently disagree and agree on many things, but the paradox is that we cannot define our prakriti without time, and nor we can define it.
Yeah, we
So
cannot
that
define time. Right.
we can't define it, but we can also live without it.
Right.
Without this concept, all our prakriti description goes away.
Right.
Okay, so that is a kind of like I would say a cosmic superposition
No,
beyond
no. So
beyond
in
Hilbert
this
space.
regard, I promised you कि I will talk briefly about the Hindu concept of time as well.
Yeah,
Because
yeah, yeah. Please go
obviously
ahead.
in the development of the idea of time, मतलब nothing to push the agenda, but it has its own place. कि because Hindus time, matlab they Hindus perceive time in a very specific fashion, and it is recently being introduced by this guy called well, I mean Roger Penrose वाला तो लोगों को पता है कि when Roger Penrose is talking about recurrent Big Bang, कि Big Bang हुआ, फिर से दूसरा Big Bang होगा, ये साइकिल चलता रहेगा.
I
So
think Neil
it's
Turok, Dr. Neil Turok also has just done some work. Dr. Neil Turok.
oh, you know that deep. So okay, okay, yeah, definitely. So you are
Dr.
really
Neil
into
Turok.
it, Bhupender. मतलब
Yes.
you are citing Niels Surya मतलब ठीक है मतलब you
Uh,
have gone
so
deep down.
actually, he
But
has done correct. He has a lecture in Perimeter Institute
huh,
where he had actually shared his idea that how we
right,
can
right, right.
actually, yeah.
There is another one more guy, Frank Wilczek. Frank Wilczek is has मतलब he's a Nobel laureate. तो
Uh,
उन्होंने रिसेंटली एक टाइम क्रिस्टल का आइडिया इंट्रोड्यूस किया था कि जिसमें there is some periodicity in time as well. And then you have the Roger Penrose idea of recurrent Big Bang and all this cyclic cosmology, जो एक्चुअली हिंदू कॉस्मोलॉजी को मतलब इसका डेरिवेटिव है. बिकॉज हिंदूज डेरिवेटिव मतलब हिंदूज परसीव टाइम एज नॉट अ लीनियर थिंग बट एज अ साइक्लिकल थिंग, कि सृष्टि होगा, फिर विष्णु जी फिर विल टेक केयर ऑफ द वर्ल्ड ऑफ द यूनिवर्स, एंड देन विल गो थ्रू अ वेहमेंट प्रोसेस ऑफ एनाहिलेशन एंड रिक्रिएशन जो रुद्रा करेगा. तो ये जो साइक्लिक आइडिया है, दिस इज एक्चुअली वेरी मच एनालोगस टू द आइडिया ऑफ रिकरेंट बिग बैंग, कि बिग बैंग हुआ, फिर दूसरा टाइम.
and this is which is actually describes it, correct?
हाँ हाँ,
The
the cosmic
cycle of,
dance.
yeah, the cosmic dance actually describes the creation and destruction of it.
Right, right. So these are very similar ideas.
Hmm.
Not only that, मैं और कुछ बोलने वाला था, हाँ. So this cycle of time, this cyclic time, is what Hindu cosmology actually postulates about. Other than that, I think I was telling this also in another podcast last time. Ki in our Hindu shastras, we sort of unify the cosmic idea of time with our own sort of physical way of perceiving time. So Hindu idea of time is also about duality. Ki कि time is something that distinguishes between day and night. Time is something that distinguishes between waxing and waning moon. Time is something that distinguishes between Uttarayan and Dakshinayan. So there is a duality in the course of time itself. एंड इस ड्युअलिटी से एक्चुअली हिंदुओं ने कॉन्जेक्चराइज किया था कि एक्चुअली टाइम हैज अ साइक्लिकल प्रोसेस. नाउ फिर इसको क्या किया, फिर इसको शास्त्र में डाला गया कि चलो एक दिन है उसमें एक दिवस और रात्रि होगा, फिर वो ह्यूमन, दैट इज वन ह्यूमन डे, ठीक है. फिर जो मून के मोशन के हिसाब से शुक्ल पक्ष और कृष्ण पक्ष होगा, दैट इज वन, मतलब पितृपक्ष बोलते हैं, और आई थिंक दूसरा कुछ पक्ष बोलते हैं. तो वो जो पितृपुरुष है उनके लाइफ में वो एक दिन है, एक जिसे हम एक महीना बोलते हैं ह्यूमन परसेप्शन के हिसाब से. फिर इन वन ईयर देयर इज उत्तरायण दक्षिणायन, वो देवता के लिए एक दिन है. फिर वी वेंट ऑन टू डिफाइन कि मनु, अलग मनु होता है, अलग कल्प होता है. फिर कुछ कल्प मिला के आई थिंक ब्रह्मा का लाइफ में एक दिन होता है, जो बेसिकली सृष्टि है. इस सृष्टि का एक दिन कैसे डिफाइन करोगे? इस सृष्टि हैज गॉन थ्रू, आई मीन द होल universe has gone through process of creation and then destruction. That is one day in the life of Brahma. और ब्रह्मा ऐसे मतलब लाखों दिन क्रिएट कर रहा है, मतलब द यूनिवर्स मे बी, एंड देयर आर मोर यूनिवर्सेस व्हिच आर गोइंग थ्रू दिस परपेचुअल प्रोसेस ऑफ क्रिएशन एंड डिस्ट्रक्शन. तो इसलिए फिर मनु ने जैसे मनुस्मृति में बोला गया कि उस
Bijit,
हिसाब से ट्रीट करो.
yeah, Bijit, I think when you are describing, correct, for a human day and a Brahma's day, correct. is different in terms of the intervals, interval of time which needs to be passed to consider one day for a human being and one day for a Brahma. There we get the concept of relativity itself. That time
हाँ
is relativity.
अच्छा,
Time,
यहाँ से रिलेटिविटी कैसे निकाल?
no,
It
no,
is very hard to.
not as a concept. That see, generally, Brahma's day is maybe 1 billion years. For me, is one day. Correct.
Right.
So in that way, it is relative. A time as a perceived thing is relative to Brahma is different, mind is different. But generally, in
हाँ,
Newtonian physics, it is same.
right. If you define the time as a as वो मतलब one dual cycle,
Hmm.
कि एक दिन एक रात होगा, उससे एक दिन डिफाइन करो, वो ह्यूमन डे है.
Hmm.
एक शुक्ल पक्ष, मतलब एक शुक्ल पक्ष और वैक्सिंग वेनिंग मून होगा, शुक्ल पक्ष कृष्ण पक्ष होगा,
Hmm.
वो भी, उसको भी एक दिन बता सकते हो. वो किसका दिन है? वो अपने पितृपुरुष का दिन है. ठीक है. फिर उत्तरायण दक्षिणायन मिला के देवता के लिए एक दिन है. So that way you are defining time, you are defining a day by from the perspective of one dual process to be completed. So
Yeah,
again
but
यहाँ पे क्या होता है, यहाँ पे टाइम और डुअलिटी फिर यूनिफाई हो जाता है.
exactly, and actually, it gives you a kind of uh, a perspective or a definition that for a devtas one day is different from a normal mortal human being one day.
हाँ,
So,
exactly,
मतलब,
exactly.
at a conceptual level, you correct, as Einstein said
You
that okay, if
elevate
you are
yourself,
travel,
right?
as Einstein said that you are traveling at a light speed and I am standing here, so time would slow down for a person who is traveling at light speed. So perception of time is different depending on the which state you are accelerating itself.
Right.
So so in that way, the conceptual level of relativity as relative perception of time for a devta,
हाँ.
for a Brahman, and for a human mortal is different, and
Right. Right.
which is actually defined in the Shastras.
Right.
That I was trying to
Agreed, agreed,
convey.
agreed. And हाँ, वही बात है कि because we don't know how to define time, maybe there are more than one ways to define time. One more point is that कि जब भी हम लोग स्पेस टाइम के बारे में बात करते हैं, in general we talk about three dimensional space and one dimensional time, so it is four dimensional space time. Or there are theories like Kaluza-Klein theory that define actually unifies, that can unify electromagnetism and gravity, जहाँ पे they worked in four dimensional space and one dimensional time. फिर आ जाता है स्ट्रिंग थियरी, जिसमें बेस्ड ऑन वेदर यू आर डीलिंग विद बोसोनिक और फर्मियोनिक स्ट्रिंग्स, जो अगेन पढ़ लो थोड़ा विकी से, मैं अब इतना नहीं बताऊंगा. बट डिपेंडिंग ऑन दैट यू आर डीलिंग विथ कि 11 डिमेंशनल स्पेस, वन डिमेंशनल टाइम और 26 डिमेंशनल स्पेस टाइम. ठीक है. ये सब ये कहाँ से आता है? ये एक्चुअली कुछ कैलकुलेशन से आता है, जहाँ यू मैच इट टू द ऑब्जर्वेबल प्रॉपर्टीज ऑफ ग्रेविटी. But then they, through by doing that, they in their theory they found कि अच्छा, maybe there are 26 dimensional space time for bosonic strings, for example. तो but हमेशा one dimensional time ही assume किया जाता है. But it is interesting to sort of मतलब imagine, frame or conceptualize कि how would it look like if time has more than one dimension. Obviously then you can go back in time, because if you really have a two-dimensional time, it will allow to not only, so if there is only one dimensional time, you are only propagating along the arrow of time. But if time itself is a plane, it is a two-dimensional thing, then you can really go back in time. So that property will be included automatically once you have more than one dimension of time. That is one thing that I wanted to discuss. One more thing that I wanted to discuss was that this arrow of time, what defines the arrow of time? Why are we only moving forward and not only, I am not, I mean, we are not able to move backward. Even in relativity, when let's say Bhupenda and I are twins, and Bhupenda went to Proxima Centauri and come back, and then he saw me growing older, And then also you're moving forward in time with different pace. It's not like Bhupendra moved backward in time, right? Why there is an arrow of time that allows us to only move forward? तो इसके बारे में भी काफी चर्चा होता है, जहाँ पे ये बोला जाता है कि most of the physical principles, they are actually symmetric with respect to time reversal. मतलब ये पॉडकास्ट छोड़ दो, बट एनीथिंग, एनी फिजिकल ऑब्जेक्ट जहाँ मतलब कैरम खेल रहे हो, तो उस पे जो मोशन दिखाया जाता है, या फिर कोई इलास्टिक कोलिजन हो रहा है, दो चीजें टकरा रहा है, ठीक है, फिर टकरा के दूर जा रहा है, इफ यू प्ले दोज मूवीज बैकवर्ड, you cannot say which movie was backward and which movie was forward. ठीक है, मतलब द फिजिकल, फॉर एग्जाम्पल न्यूटन्स लॉ ऑफ मोशन, न्यूटन्स लॉ ऑफ मोशन में एक पार्टिकल को रखो जो मूव कर रहा है, जो फोर्स फील कर रहा है, एवरीथिंग यू डू एज पर द न्यूटन्स लॉ, यू क्रिएट दिस ब्यूटिफुल सॉर्ट ऑफ caroms and little billiard balls, and you film the process, and then you run it backward. No one will be able to tell you कि these movies running forward or backward. So Newton's law are symmetric with respect to time reversal. Similarly, uh, much of the quantum field theory that we have discussed, and pretty much most of it, is actually they are invariant. They are the same with respect to time reversal. मतलब if you reverse the time, you won't be able to distinguish कि something anomalous is happening. Okay. uh, so this is one thing also. This leads to one more thing, which is called the, you go and read about it, one electron theory. One electron theory is proposed by this guy called Wheeler, John Wheeler, who proposed ki because in quantum field theory it is allowed for a subatomic particle to go backward in time, at least theoretically it can. And that's why maybe all the electrons that we are seeing. So he asked the question to Feynman, Feynman, do you know why all electrons look like the same? And then he answered, it is because they are all the same electron. So which means ki if you imagine x versus t, okay, this is the position versus space, and let's say you allow the electron to move backward in time as well, then pretty much at a given time segment, it can go back electron and then come back. So once an electron is allowed to go back in time, then all the electrons that you see around, maybe they are the same electron, just going backward and forward in time. So this is the one electron theory, and from there, Feynman took the idea a little bit to create the Feynman diagram. So in the, when you calculate the Feynman diagram in quantum field theory, there also you allow the particles to move backward in time for a little bit. ठीक है, मतलब this, a little bit of this thing is allowed. And Feynman wrote about it. It is not like, मतलब now modern scientists they sort of ignored this thing, but Feynman wrote कि हाँ, due to uncertainty principle, or at least some manifestation of it, for a very small while, a particle can go backward in time. That's how he perceived the Feynman diagram that he created. So this is his own word. I'm not trying to create again any controversy here. I'm just quoting Feynman himself, who calculated Feynman diagram and invented Feynman diagram. Anyway, तो फिर, so मतलब if all the physical principles are actually invariant with respect to time reversal, then why is it that time is always moving forward? Why is it that there is a single direction in the arrow of time? So every principle is symmetric with respect to time reversal, except one principle, I would say, which is not even law, but it's a statistical principle or a statistical law, which is the second law of thermodynamics, where you have the sense of entropy. So I am saying ki if you have a glass, and if you have a glass made of glass, right? I mean something that can break, and if it falls down, ठीक है, तो टूट गया. If you play that movie, मतलब you will be able to distinguish between the forward in time forward and whether the movie is running forward or backward in time. क्योंकि एक टूटा हुआ ग्लास फिर जुड़ के मेरे हाथ में नहीं आ सकता. दिस इज काउंटर इंटू. बिकॉज देन यू विल बी एबल टू से कि ये मूवी को पीछे मतलब बैकवर्ड चलाया गया है. Why? Because once the glass fell from my hand to the floor, and it broke, the entropy has gotten increased. So it is that the universe always move from a minimal entropy to a maximal entropy overall, and it is the amount of entropy, the increase of entropy, that defines the arrow of time. um, तो इस पे काफी चीजें अभी भी रिसर्च में हो रहा है, which actually make us claim कि बिग बैंग के टाइम में शायद कोई एंट्रोपी था ही नहीं. इट वाज द स्टेट ऑफ मिनिमल एंट्रोपी. इट वाज वेरी स्मूथ. एंड देन इट फर्दर create another question कि universe at the beginning, why it has such small entropy. Could have been anything. It could have started from any finite amount of entropy, right? It could. Why did it start from a minimal entropy position? So these are all the stupid questions that physicists ask. Maybe these are trivial questions in someone's perspective, someone's point of view. But these are the very basic questions. These are the fundamental questions that physicists try to answer, and in the process, they create new physics all along.
Yeah, okay. So just to add up, like people who are interested in understanding entropy, so you don't have to go and read a book. Read a story called The Last Question by Isaac Asimov. So you will
Huh.
understand. So you don't have to go and read a textbook on entropy. Go and read the story by The Last Question by Isaac Asimov. You will understand what entropy actually means. So it's a fun way of learning about it.
Right, right. And it is actually, it can get very depressing. The guy who defined these things, right? The Boltzmann, Ludwig Boltzmann. No one accepted this theory, right? I mean, his definition of entropy, the statistical mechanics that he formulated. So he committed suicide actually, and now it is your time to learn the same thing. Yeah.
Yeah, so learn like scientific concepts from stories. So like reading about science fiction stories and a bit of novels would actually teach you a lot of science than whatever textbook teach you actually.
Right. I mean, see, I find the philosophical part of physics pretty fascinating. I mean, that's why I did it, because I wanted to get answer of many questions that I had, right? When after I completed my BTech, so I had to study this theoretical physics. Yeah.
Yeah, so we'll now take some good questions. We have a few questions
Yes.
which are there. So let me just pick them one by one. So this is a comment which actually Bojaleji made. Newton was speculating as though there is a communication between two bodies, kind of a theory of Jagdish Bose who postulated botanical and cellular communication.
Right. 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 That is true. I mean, he this is called action at a distance. So Newton was actually wondering why there is an action between the sun and the moon and the earth from a distance. I mean, what is creating this tide when the moon is so far away? How does it know that there are this much water in the ocean, that I have to sort of attract towards me? And we
Yes,
know right
so
now it is actually, in terms of Einstein, this is the space-time curvature around. So the sun create a curvature around it, very soppily showing it is just like if you have a mosquito net, you put a ball there and then it make the curvature, right? And then if an
it
ant
looks
trying to
like this.
uh,
So this is your space and this is sun. So it will create a kind of a bend. It will bend down. So the space will
bend the
actually
space time,
curvature will it will create a curvature. It will bend down. So
right? And
same way it is understood by Einstein in the relativity.
right. I mean, so then if again it is a sloppy description, but
Yeah.
it is an analogy, and analogies are never completely wrong. Okay, so the point is ki then whenever the Earth is trying to move in straight line, because of the curvature, it is making a full circle. Well, not completely full circle, but yeah, for all practical purposes, we can say that the straight line motion of the Earth, because of the curvature of the space time, is becoming a full circle. It is becoming a geodesic. So, for example, if we start walking straight, starting from any point on the earth, we will think we are walking straight in a straight line, but then we'll come back to the same point. Why? Because the earth itself is curved. I mean, the surface of the earth is curved. It is actually a spherical surface. So, what we are thinking of a straight line, the straight line in a curved surface become a geodesic, and the geodesic of the earth is actually a circle. That's why the straight line that earth is creating, otherwise earth, at least if it is thinking it is moving in a straight line, is creating a geodesic around a full circle around the sun. Right. So that is action as, at a distance. It is the curvature. If you forget about curvature, if you really treat gravity as a field, and Laplace did that to answer this question by Newton, there he assumed that the sun is creating a field around itself. So this is the again field theory idea, and this field around the sun created by the sun is actually propagating to the earth and talking to the earth and dictating how it is supposed to move.
Yeah, so this is the one very interesting question. So, do you think that objective reality or everything is relative?
Right.
Very interesting and very Go ahead.
I do believe there are objective realities. There probably is one objective reality. And in support of my statement, I am going to give you a few philosophical sort of understanding that I have. So, for example, whenever we talk about relativity, I mean, even in relativity, right, we talk about the fact that space and time is relative. But even in that theory, we have an invariant quantity, which is the speed of light. Um, when we talk about Maxwell equation, there also we have invariants like speed of light, and we have the permittivity of a medium of vacuum, and all these things, right? So no matter what theory we try to create, there is always some invariant quantity around which we judge the dynamics, we judge the sort of relative motion or everything that is happening, right? In the Newton's theory, you have the mass of the sun, mass of the earth, distance. These are the invariants, sort of, right? If you assume Earth is performing a circular motion, right? And then you extend it to, let's say, Kepler's idea, that Earth is not rotating in a full circle, but it is elliptic. Then you have one more objective parameter, right? Invariant parameter, which is so there are two parameters: the major axis and the minor axis of an ellipse. So yeah, so this is my answer. Ki no matter whatever relative, how much amount of relativity you introduce in a theory, you have to deal with some constant parameters. And right now we have detected around 23, 24 objective parameters that are actually running the universe. And if the value of those scalars, those parameters vary even by a little bit, it will create huge chaos in the whole universe. Right? Those are like assumed to be invariant constant parameters, and they dictate the reality, right? So this is one part of it. The next part is that so why one objective reality or one equation? So let's say you have, like, why we are moving towards this unification, which is apparently in contrast with the Hindu idea of diversity, for example, or right, in some apparent contrast. Why we are saying we need one equation? This is because, let's say, you have two principles, right? One is, let's say, Newton's law, which is governing the motion of the planets, and we have, let's say, quantum mechanics, which are explaining things moving in nanometer scale. Now these two laws, they are working very nicely in their own paradigm, but then there will always be some scenarios where they both will have some substantial effect. right? So, for example, you can imagine what will happen around a neutron star. What if two neutron stars are rotating around each other? So these are cases where you have to deal with the quantum mechanics and some amount of Newton's law. And it because physical, whatever you are going to observe for that physical process, these two laws, when you apply them separately, they should not give you two separate answers for the observable reality. So it is only feasible, it is only practical that these two laws will merge in that specific context to either give you a new law, or one of them will, or both of them will be discarded, and one new law will emerge that will sort of take care of those edge case scenarios as well as the independent paradigm of the previous two laws. Okay, so by judging all these edge case scenarios, because all the edge case scenarios should be covered, that's why all the physical sort of principles or the laws or equations that we write, they should merge towards a common equation that will potentially capture all the edge case scenarios and all the independent paradigm of the little Maxwell or Einstein or Newton equations. That's why I think there should be an objective equation, and there could be an objective reality as well. Because, yeah, so let's not go into the sociology part of it, but yeah, because we are in the physics podcast
Yeah.
right now.
So to actually give Hindu perspective, so the concept of Maya, okay, the Maya, which is discussed in detail in Bhagavad Gita as well, okay, Gita, and also it is discussed in Upanishad. So if you see the concept of Maya, for a Maya to exist, there needs to be a correct. There is a called Brahman, okay, the ultimate consciousness. The ultimate consciousness is called Brahman. So, and from there you have Brahma, who is the creator. So you have a Brahma who is creates things, okay, and so as a ultimate reality is Brahman as per Upanishads, okay. So there is an objective reality called Brahman, and a, uh, it projects itself as a Maya, and that you see around us. So that's Upanishad. So even if you believe in Upanishad's philosophical aspect of it, there are some aspects which are actually more than philosophy. But just take it, for example, as a philosophy. For Maya to exist, there needs to be a objective reality which is projecting the Maya to you. So even if you reverse the logic, you will have an objective reality which needs to be there for Maya to exist.
Right, right. Agreed.
Yeah. Okay. Let me take.
Is there absolute nothingness? What was that question?
Okay, the last question was, yeah, in absolute sense. He mentioned that, okay, so there is something or nothingness in ultimate sense. That's why I told him that the ultimate reality is Brahman. Okay. So, and Brahman projects Maya to you, and that you perceive as objective, as a kind of subjective reality of you being a material human being, where you have mind, where you have body, you have everything else, material things which are there, but they are Maya according to Brahman's projection. So you exist as a physical human being, okay, and that existence is because it is being projected by Brahman. So both actually exist in their own realm. So this question comes that which is the real existence? They both exist in their own plane. One cannot, so you cannot perceive the ultimate consciousness without having Maya, because then there is a reference frame. So from your reference frame, from Maya, you will be able to understand, okay, if this is Maya, then there is a reference frame which is the ultimate consciousness, Brahman itself. So both really exist, but you need to understand, okay, my existence, my physical existence is reality, but this reality is a projection of a something greater that is called Brahman. So in that way.
Right, right. In the sense of theoretical physics,
Hmm.
this is a very interesting question from that perspective. So I would
Hmm.
also want to catch that part.
Hmm.
So yeah, like there are things like, okay, maybe during this Big Bang there was nothingness, inside black hole there is nothingness. All these things. Maybe, I mean, Big Bang is the sort of mathematics that cover the Big Bang scenario and the mathematics that cover the black hole scenario. They're pretty much the
Hmm.
same
Hmm.
kind of mathematics.
Hmm.
And exactly, it talks about some sort of a vacuum, some sort of a void. And even in the concept of theoretical physics, the void and vacuum are not the same. So the void is sort of absolute nothingness, but in vacuum is something which allows virtual particles to exist. Which by that I mean ki ki theoretically you can create particle and antiparticle from nothingness. If you merge the quantum mechanics and relativity, there is always some sort of energy uncertainty, right? There is always some sort of delta E that is there. So, as per the uncertainty principle, for a very small amount of delta T, small amount of time, you can have matlab small amount of delta E, the uncertainty in energy, which can create virtual particles, let's say electron and anti-electron, which can propagate for a very little time before they merge onto annihilate each other again. So in the concept of physics, the void is an absolute vacuum, an absolute void where there is no quantum mechanics or relativity, or at least they are not creating these sort of particles, virtual particles, virtual particle antiparticle pairs. But in physics, a vacuum is something which is extremely dynamic in the sense that as you go deeper and deeper into 10 - 9, -15, -18, -30, you will see a lot of like everywhere virtual particle antiparticle pairs are being created and highlighted. Again, they're virtual, so you cannot observe them, but you can feel their effect. So in particle physics, in quantum field theory, vacuum is a very dynamic place. Okay, and hence the idea of nothingness actually falls short from that perspective. But let's say you start to create things from nothing, right? Like you can ask initially maybe there was nothing from which things got created, and there are theories like various. I think Hawking himself gave a theory where he indeed created an universe from nothingness through quantum froth or quantum bubble kind of thing. But the issue there is ki it's the same thing. You have nothing, you apply the uncertainty principle, and due to the uncertainty principle, you can sort of emerge an universe out of nothingness. But you have to see ki even in his equations, it's not like ki there was absolutely nothing. What there was his equations. So he used his equation in nothingness in order to create something. Now you can go back and ask the same question. Ki now, does the equations, does his equation have a separate ontological existence? I mean, very saying it in a very easy words. Like an equation, does it emerge from the pattern around us? Is it that we observe the pattern around us and write the equation? Or is it that the equation is supreme? It is sitting somewhere in some abstract space and creating the universe that we observe around us, right? So it is actually a huge question key, which is ontologically fundamental, right? Is it the equation? I mean, even if you had nothing, when you, matlab, as per whatever, say, ki God says there was light and there is light, something like that. No, God had a principle, right? I mean, some principle was imposed upon nothingness to create the universe. So it's an interesting question. Again, we don't know the answer, but these are the thought processes that we use to discuss this question.
Okay, so we will take two more questions and we will round up for the day. So this is interesting. Okay, so there is some misconception. Okay, so theoretical physics leans towards Brahman instead of Shunyata in Buddhism. First of all, Shunyavad is not an original Buddhist concept. Shunyavad exists within Shaivism. Okay, so Shunyavad or Shunyata, okay, is a Sanatani Hindu concept, a kind of a philosophy, which was and 100% of the Buddhist philosophies are actually derived from Hindu concepts, Hindu philosophy itself. So it
Essentially,
is
there is no
not Buddhist.
difference. I mean, yeah, right,
Yeah.
right.
So exactly. So there is no difference. So whatever philosophies that you see, which is are propounded, which are worked upon, They are actually Sanatani or dharmic philosophies, which are actually they took it and worked upon it, and good that they did actually. So there's a lot of
No,
work is.
see, in
Hmm,
Hindu scripture,
hmm.
we perceive shunyata as a non-dual concept and shunyata not as an emptiness. You have to understand that shunyata comes from non-duality. I mean, when you talk about shunyata, you are talking about a state which is non-dual. So, for example, when you talk about duality, the world is dual. Why? Because there is day and there is night, there is good and evil, and all these things. But these are dual ideas. Hinduism is saying that there exists a state which is a Brahman, which is a Shunya state, in the sense which is a non-dual state, which does not have good and evil, which does not have day and night, which does not have light and shadow, which does not have existence and non-existence. Okay, which is not, which is neither, which can neither be expressed, nor can be unexpressible. So this sort of non-duality is what Brahman is. It is not a shunya, ascetic, empty, nothingness that is shunyata as per Hindu Shastra. I mean, I am saying this because from this fundamental misunderstanding of shunyata emerge these ascetic ideals. You have to move towards this sannyas. You have to, you have to whatever reject everything. You have to be like, an ascetic and all these things. No, shunyata means you have to attain a state where you can see the duality, where the duality would not bother you, where you will be a drashta, to which you can see the dynamics of the world in terms of duality. Because inside you will be a very non-dual entity. That is Shunyata and that is Brahman as per me.
Yeah, so let me just show you something which actually people would not have read. So in the Taittiriya Upanishad utilizes the neti neti, nor this nor that. Okay, not this nor that principle to explore the nature of Brahman, the ultimate reality. So when you talk about, it's a very complex thing actually. So there are a lot of talks on it. So the Buddhist concept of shunyata is that whatever you see around, its existence depends on something else. So that's what the crux comes down to. That this is a, a earphone socket. So it exists because there are metals. There are metals exist because you have ore. You have ore because you have mountains. So shunyata means that okay, nothing exists on its own, and that's how the sunyata is defined in Buddhism, actually in Buddhist philosophy itself. So here the same thing actually exists here, that you have a ultimate reality which is Brahman, and that you cannot describe by any other means. So then again you have this concept of zero or shunyata, something which is beyond duality. So that's why in you have in Upanishad, and in also you call correct Advaita, non-dual philosophy. So Upanishad talks teaches us that non-dual concept of Brahman rather than dual concept of Brahman. So it all comes to a lot of complex things that you can go and watch a lot of YouTube videos about it. Yeah, Vijay.
Right, right. And yeah, so based on this, I mean, actually, my next, these sort of things are topic of my next book because I'm working on a coherent sort of philosophy. Is matlab, ठीक है, Hindu philosophy है, but I'm trying to put it in the modern context as well without subverting it, obviously. Where I'm discussing things like intention morality, spontaneous morality. And there also spontaneous morality is something which emerged from a non-dual entity. It is spontaneous, unlike intention morality, which lives in the causality of the world. See, in a physical world, you have the chain of causality. You have cause, you have effect, and they are connected by chain and all these things. But when you become Brahman, you sort of, you're said to be developed a sense of an entity which is beyond the physical world. What does it mean? It means that you go beyond the chain of causality. Because causal chain is a physical chain, it has a duality. You go beyond duality. You become shunya, where you are not bounded by the chain of cause and effect. In fact, you can see, you become a drashta of the causality that is happening around the world. And that is Brahman as per me.
Yeah, so we will pause because it's so Abhay. So like your questions are very good, but you need to go and because I cannot answer because I'm not. I have read something and so I can't give you the answers. What you can do is you can go to YouTube and there are a lot of lectures by various authorities who can give you, and you need to spend time to actually understand this. So it will take you maybe 1 or 2 years to actually get to a conception level where you can actually relate to Shunyata, relate to Upanishad, relate to Tatriya, relate to non-duality and find something which is coherent. So go on a journey and so we'll take the last question and we'll end this today. This is the last question we'll take. What can Hindu concepts contribute to further development of physics?
Non-duality, Advaita. In
Yes.
future it is going to be used again and again, because you see this space time and all these things, they are dual. Why? Because in space you can create x and minus x. In time similarly, you have causality, cause and effect, right? So to write something, to write an equation which is beyond these things, you have to manifest non-duality in your equations, in order to explain anything which is getting singular, which is not bound by the typical canonical idea or the quantum field theoretical idea of space time. You have to go beyond the duality of physics. Physics is chained in duality. In order to free it from the chain of duality, you have to incorporate non-duality in your physics, in your physical equations, if you are trying to become a theoretical physicist. And yeah, non-duality is going to play a big role there, in my opinion, in framing the future development of physics.
Yes. So there is an organization called Essentia Foundation, and they have done a lot of good work actually to actually merge these two, not non-duality, but as a kind of consciousness studies. So if you want to know more about it, you can just search Essentia Foundation on YouTube, and you will see a lot of videos where they talk about this specific, not specific, but related to this topic. So that's
Right.
a good way to start. And the last thing that I would say, see, uh, in terms of correct emptiness. So the emptiness that physics talks about, that is, nothing is there. But in our scriptures, it says that okay, uh, I think Vishnu says, okay, I exist in every part of existence. करेक्ट विष्णु शेष के
Gita,
मैं
right?
कण कण हाँ हाँ, मैं कण कण में हूँ सॉरी हाँ तो मैं कण कण में हूँ ठीक है so every I exist everywhere. Right. So if you take as a symbolic representation, it means that energy exists everywhere, including in vacuum.
Yeah, maybe energy, maybe principle. Who knows, right? Yeah.
Yeah,
Some
I'm
abstract idea.
yeah, just as a symbolic representation. When
Right, right.
when Gita says that like, I exist in every single particle, God exists. Okay. So end of the day, correct. Everything comes down to energy and matter, as a positive matter and positive energy in general, correct. And they are somewhere down linked because they are created from a single entity. And then you have
Mm.
their dual states where you have matter and you have energy. So if you see in other way, they are the same. They are just different representation. They are different phases of the same thing. So
Right,
in
right.
in that way, you can conceptually and symbolically find if you can go beyond the semantics by understanding the concept, understanding the overall architecture, what is being said. Okay. Rather than talking about, okay, they are talking about a bird. It is not a bird. Bird is a representation, a symbolic representation of something else. Garud. Okay.
Right, right.
So if you can understand and go beyond the general rhetoric, you will find something which is kind of enlightening in so many
Huh.
ways. Yeah. So thank you. I think it was a very fruitful and quite interesting discussion we had. So we'll
Right.
continue. We'll talk few more of this topic. So for
Sure.
people, just to share, let me show the portal as well where you can get the book. I have put the links in the description as well. So there are two books which are available. So this is how it looks like. So this is the book that we are reading. There's one more book called Kāla. So there are theology of these books. So Kāla, the Darshan, philosophy of time. You have Kāla. So these two books are available, and there will be third book also will be coming. So and you can go to Garuda Books. You can get it. I have put the link there. So it's not very difficult book to read. Like yeah, it will take some time to actually get used to it, but it's a readable book for even normal person can read it. So don't worry about that. This book is very difficult. It's very easily written for a common person as well. But it's very interesting to actually keep your philosophy and keep your life in bit of a interesting thing that you can have a different perception of time. Okay, rather than just looking at your watch that I need to go to office. So time is beyond your office time. Okay, so thank you, Vijitda, for
Yep.
your time.
Thank you.
Okay,
My
yeah,
pleasure.
yeah, yeah. So Jai Shri Ram, Vande Mataram.
Jai Shri Ram. Vande Mataram.